This video is there to get you started with React.js, arguably the most popular JavaScript library for building modern, highly reactive user interfaces. I do have a complete course on React.js, which of course allows you to dive way deeper into React if you want to, and dive into more advanced features and important third-party packages as well. But with this video here, you will already get a solid foundation which you will always need as a React developer. We'll explore all the key concepts you must know, and we'll explore them by building a demo application so that by the end of this video, you'll be able to get started building your own basic React applications, and you're ready to dive deeper into React with my course, or of course also with our resources. Either way, for this video here, you need no prior React knowledge. Basic JavaScript knowledge is enough, and therefore let's dive right in. Now, to get started, let's start by diving into the most important question first. What exactly is React.js? Well, the official website tells us React is a JavaScript library for building user interfaces. And that's a nice sentence, but what exactly does it mean? Well, obviously, it's a JavaScript library, so we will write JavaScript code. We use React in conjunction with our own JavaScript code, but it is a library that's there to help us build user interfaces. And I might add that it's there to help us build highly interactive user interfaces. You don't necessarily need React if you build a simple web page on which not a lot of things are happening. But if you're building a more interactive website, like the demo project we're about to build, then React.js can be a huge help, vastly simplifying the code you have to write. And to show you what I mean, consider this very simple example here. I got this user card where I have this contact button, and if I click this button, this modal overlay opens up, and there I can enter some address and submit it. Now, this is not super fancy, but we have a website with some interaction on it. We have a website where I can open this modal and enter data and submit it. Now, on this demo website, nothing's happening to that submitted data, but we do have a website that does support some user interaction that must be interactive and reactive because we must react to button clicks and open this overlay. And even though that's a pretty simple example and a simple website here, the JavaScript code we could write to make this website work this way and to make the website behave that way when not using React.js could look like this. And whilst this is of course not too much code, it's quite a bit of code for this simple interaction. And it's probably easy to imagine that if we had a more complex website with more user interactions on it, we would need to write a lot more code, and of course, therefore, we would introduce more potential error sources. Now, when building the exact same application with React.js, the code suddenly looks like this, combined with this. And whilst this is still some code, it's a bit more readable and easier to manage, and as soon as you know React, which you will do by the end of the video, it's also much easier to read, as you will see. Because even though you don't know React yet, you can clearly see that we seem to be writing some JavaScript code where we have some HTML code blended into that JavaScript code. And we then have clear instructions like set show modal, which seems to do something, which in the end leads to that modal being shown conditionally. And again, I will teach you all that code and React syntax and all these React features step by step throughout this video. You don't need to understand them yet, but you can probably see that we have some clear instructions here and some clean code, and most importantly, some HTML code blended into the JavaScript code, which is a feature that's supported by React and by the React projects we'll be working in, as you will also learn in this video. In case of the raw vanilla JavaScript code, we just had step-by-step instructions where we tell the browser step-by-step what should happen on the screen. That we want to add an event listener, that we want to create a new HTML element, how it should be configured, where it should be added, and much more. We have step-by-step instructions, and indeed we call this approach of writing code the imperative approach, where we have step-by-step instructions simply describing step-by-step what the browser should do. On the other hand, when using React.js, a major benefit of doing so is that we're able to write declarative code, where we write the code for the UI that should be output on the screen, and we blend some syntax like event listeners or dynamic values into that HTML code, and combine it with extra React features where we can, for example, define different states and under which circumstances these different states should be active. And React.js will then generate the appropriate instructions for the browser under the hood so that as a developer, we don't have to write these step-by-step instructions. And that is indeed one of the major benefits highlighted on the React.js website as well, the fact that you write declarative code when working with React. Now again, this is just a simple example with a lot of code we don't know yet, but that's one of the major advantages of using React. We often can write much simpler code and therefore actually build way more powerful user interfaces. So let's get started with React then. And to get started, we first of all must create a React project. Now, when working with vanilla JavaScript, creating a project is as simple as creating a new folder and adding a bunch of HTML, JavaScript, and CSS files in there. Now, when building a React web application, a React website, it's not that simple. Instead, you need a project that performs various behind-the-scenes code transformations automatically, and you typically also want to have a nice developer experience where the React app you're working on is previewed and automatically updated whenever you change the React code. Now, the behind-the-scenes code transformations are needed because, as I mentioned before already, when building React apps, you typically blend HTML and JavaScript code in one and the same JavaScript file. Now, technically, this is not valid JavaScript code, though. The browser would not be able to execute this code, and we will, of course, learn why we're blending the code like this in just a second. But it is important to understand right now already that this code would not run like this in the browser. That's why it must be transformed, compiled, you could say, to some valid client-side JavaScript code that's supported by the browser first, so that we as a developer have the convenience of mixing HTML and JavaScript code, and as an output we still get code that's supported by the browser. And that's why we need a project setup that comes with some built-in tools that give us this live preview with the auto reloading upon code changes, and where we also get our code transformed under the hood so that once we're done building our React app, we get a website that can be deployed on some hosting providers and that can then be visited and be viewed correctly by visitors from all over the world. So we need a project setup that supports these requirements, and a popular tool for creating such projects that come with all these features and tools that we need built in is Create React App. This is a tool which you can use to, well, as the name suggests, create React apps that give you this auto reloading and that support this HTML with JavaScript syntax. An alternative tool which you could use is Vite, which can also be used to create new React projects. And you can simply follow the instructions shared on these websites of Create React App or Vite to create valid new React projects. Now, for both tools and also to successfully then run the projects created by those tools, you must have Node.js installed on your system. Now, you don't need to be able to write Node.js code. You don't need to know Node.js, but Node.js is used under the hood by those tools that create the projects and then also by the projects and their built-in tools as well. So make sure you have Node.js installed on your system. You can typically download the latest version of Node.js or use the latest LTS version, the latest long-term stability version. And once you got it installed, you can create those new projects with npx create React app to use that tool, or by running npm create Vite to use that Vite tool. And I'll do that, but you can use either of the two approaches. Now, once you run these commands, you're typically asked to choose a project name. And here I'll just name it React Crash Course, but the name is up to you. And then in Vite's case, pick a template where I'll pick React and then JavaScript. And this now creates a new project. Now, once that was done, you can open that newly created project with an editor of your choice. In my case, I'm using Visual Studio Code. And you can start working on that code there. Now, if you use the Vite, you also must open the terminal first and navigate into this folder. And for that, here I'm using the built-in terminal in VS Code, which is already navigated into that folder by default. And run npm install to install any extra third-party packages that are needed to build and run and preview your React application. Once that's done, you can run npm start when using a project created with create React app and npm run dev when using Vite, which I do here. And then you can visit the website on this address, which should be output in the terminal, to preview your React app. And the exact output on this screen here might change over time, but you now have a basic React project which we'll now use to learn React. As a side note, attached you also find a link to a project snapshot which I prepared, which was created with help of Vite and which I also cleaned up a little bit so that we can all start with the same starting state. So feel free to also look into this starting snapshot and use that starting snapshot to follow along. So here I am now in my brand new project which I created using that starting snapshot, which was also attached to the last lecture, so that you can simply download that starting snapshot, which was created with help of Vite and which I simply cleaned up a little bit so that we only have a few files in there. And this is now the starting snapshot we'll use to dive into React and learn about these React essentials. Now, to briefly get you started with the project we have here, a project created with Vite in this case, in the end what I do have here is an index.html file, which isn't too important for us here because we won't add any code to that. Instead, we will work in the source folder where we have some .jsx files. And in the end, these are JavaScript files that also support HTML code inside of them. This special syntax which I mentioned, which is not supported by browsers, but which is transformed under the hood by the project setup we have here into code that is supported by browsers. This syntax of having HTML in JavaScript is called JSX, and that's why these files have these special JSX extensions. But again, this is not supported by the browser, this is transformed under the hood instead. What's also worth noting is that I have a CSS file here with some basic CSS styles, and this file is also being imported here into a JavaScript file in the end. Normally, this would also not work in the browser, but this is another feature supported by this project, which is then transformed under the hood. And you can kind of see what it's being transformed to by opening up the developer tools in your browser for this starting snapshot website. And there in the head section, you, for example, see that a bunch of scripts and styles were injected. For example, the styles that were defined in this extra CSS file. So this project setup and some tools that were installed as part of this project setup simply detected this CSS import and therefore included this CSS code in the final website that's being loaded. You also see that a JavaScript file is being loaded here, which, if you take a look at it upon loading this website, in the end contains the transformed JavaScript code, where you no longer see HTML code as part of the application, but where you instead have some raw optimized JavaScript code, which in the end is responsible for outputting on the screen what we see here. So that's what we got. That's what we'll start with. That's this special JSS syntax, which will become important when working with React. And with all of that out of the way, let's now take a closer look at the code we have in these two JSX files. Because there we have some strange code which clearly seems to be responsible for outputting hello world, but it probably makes sense to understand how these different code pieces work together and what's happening here. So what's happening in these two JSX files? Sure, we have this HTML code in there, which is called JSX, as you learned, but what exactly is this code doing here? Well, let's start with main.jsx. I can tell you that this is the main entry file of the entire application. The code in this file is executed first when this website is being loaded in the browser. But what's this code doing? Well, we're importing some things from React libraries. This is in the end the modern JavaScript import syntax, which is also supported by this React project we created here. And we are importing some features from the React library and from the React DOM library. Now, these libraries are installed in this project with help of this package.json file. If you take a look at this package.json file, under dependencies, you find React and React DOM. Now, package.json is a file that's used by Node.js for managing the dependencies of your project, the third-party packages you want to use in your project. And it's also commonly used by front-end projects where you don't build Node.js applications for managing the packages of those projects as well. So therefore, this project, which we have here, which I created with help of Vite, but it would be the same with Create React App, uses the package.json file to define external dependencies, to define which third-party packages will be used in your code. And here we're using React and React DOM, which are simply two separate libraries created by the same team, and these two libraries together form React, the React library, you could say. It's simply a combination of two packages. Now in main.jsx, it all starts with this React DOM thing, because there we call the create root method. This method takes a pointer at an element in our HTML code. And this is indeed regular vanilla JavaScript code here. Document get element by ID is not React specific. And what this code does is it reaches out to this element here, which has the ID root in this single HTML file that we have in this project. It's the only HTML file in the entire project. So this code here in main.jsx reaches out to that root, to this div with ID root. And then it calls the render method in the end on this object returned by create root. It calls the render method, which is a method provided by React, by that React DOM part of React to be precise. And we then do this. We then pass some JSX code to render. And in the end, this simply tells React that inside this div with ID root, or in general, the element with ID root, this React code should be rendered, so should be displayed on the screen. Now, this strict mode thing here is a special feature offered by React, which simply enables some extra checks warning us of potentially suboptimal code we could be writing, also in regards to future changes that might be added by React, where it wants to warn us if we write slightly outdated code or anything like that. The more important part is this app thing here, because this is actually also being imported. This import, where we import app from ./app, that in the end gives us an app thing, an app element, as it seems, which is then rendered here with help of this JSX feature. So by using it like a HTML element in our JavaScript file. Now ./app simply refers to the app.jsx file. For JavaScript and JSX files, you can and should omit the file extension here in your import statements, and therefore this refers to app.jsx. And in there, we are exporting a function called app. That function is a very simple function. All it does is it returns more JSX code. It returns the h1 HTML element with a text of hello world inside of it. Now this is a so-called React component, and React is all about components. When you build React apps, you in the end build components, and components are simply functions that return JSX code. It's not entirely true. Theoretically, there are a few other things they could return as well, but typically they return JSX code. So functions that return JSX code are React components. And React components can be used in other JSX code. That's why this app function, as we just learned, which is imported in main JSX, can be used like a HTML element in this JSX code, which is passed to render. Because render wants in the end some HTML code, some JSX code to be precise, that it should output on the screen, and we can use our own component, the app component, as part of that JSX code. Now our own component, the app component, returns this h1 element, and therefore ultimately it's basically this h1 element which is passed to render between those strict mode tags, which we can ignore. And that's why we see hello world on the screen here, the content of this app component, which we have here. And I am aware that these are a couple of new concepts. JSX, components, definitely some new stuff here. But they are also amongst the most important concepts React has to offer. Because React is all about you writing your own components, so your own functions that return HTML code in the end, and using these different components for then composing a more complex user interface. Because components are a key building block when working with React. Ultimately, any website you think of can be split up into different building blocks that make up the website, like a header at the top, a sidebar on the left, and so on. And with React, you simply build these individual building blocks as functions that return JSX code. And by combining these building blocks and potentially nesting them into each other, you can build complex user interfaces in a granular, easy to manage way. Now, it's not the only important feature added by React, but it's a key feature nonetheless. And therefore, as a next step, we'll start building our first custom component together, instead of just working with these predefined ones. So let's get started writing our first custom React code by building our first custom component. As mentioned, components are these functions that return JSX code, and as a React developer, you'll write dozens and hundreds and thousands of those components to build up your React applications. Now we're about to build a Twitter-like demo application where random people can post their stuff for the entire world to read it. Amazing. And along the way, whilst building that application, that demo website, we'll dive into many core React features. And we'll get started now by building our first custom component. Now for this demo application which we're about to build, there are actually multiple possible components we could identify. We could, for example, build this button as a separate component, or this list of posts, of tweets, if you want to call it like this, or the individual tweets. And indeed, that is how you should think of components and React applications. We have all these building blocks, and we then build the overall UI by combining them. Now, of course, you don't have to put every single character into its own component, but it makes sense to group related functionalities together into different building blocks. And here we could, for example, start by taking a closer look at the individual posts. And the first custom component which I want to build together with you, therefore, is a component for such a single post. And later we'll be able to then output multiple posts based on that custom component. Now, therefore, back in this project which I gave you, I'll go to that source folder and in there add a new folder called components. Now, this name is up to you. You don't have to name this folder components. You don't even have to create a folder in the first place, but it makes sense to group your component files together into such a folder. Now, this app.jsx file, which technically also contains a component, is not part of that folder because that will soon be our root component. And I'll get back to the concept of our root component later. So for the moment, let's go to components, and in there I'll add a new file called post.jsx. The name is of course up to you, but post makes sense since we're about to add the code that defines a single post in there, the markup that defines a single post, for example. And .jsx is required because we plan on writing some JSX code in there. If we had just .js, that would work in projects created with Create React App, but Vite projects actually want .jsx to support JSX code in JavaScript files. And now as a next step, we have to create a function, because React components are just functions. It's as simple as that, regular JavaScript functions. With one special gotcha though, the name of your functions should start with an uppercase character. And of course, the name also should describe what this component will be about. So here I plan on defining the markup that defines an individual post in that grid of posts, and therefore I'll name the function post like this. And the uppercase starting character is important. It's not required technically in here, but it is a recommendation and it will be required later. Now this function should be exported so that it can be used in other code files as well. And for that, you can use the standard modern JavaScript export syntax, where you either export it like this by adding the export keyword in front of the function, or as a file default. And the only difference is then regarding how you import that function in another file. So here I export it as a default, and now in that function, as mentioned before, we should return some JSX code, because that is what turns a regular function into a React component. It's really only the fact that you start with an uppercase character, and even more important, that you return some JSX code. Now, for a single post to get started here, we could return a div, and then in there maybe a paragraph where we output the name of the author of the post, and below that another paragraph with the post body, like React.js is awesome. Now, after hitting my auto format shortcut here in VS Code, I get this function, and that is now indeed our first custom React component. But of course, if we just add this file like this and save all changes, nothing changes on the screen. And by the way, you must make sure to keep that npm run dev process here up and running. In case of a Create React App project, it was npm start. With Vite, it's npm run dev. And this starts a development server which watches your code files, serves your website on the address that's being output here in the terminal. In my case, localhost 5173, so that you can preview your React website there as you're building it. And it will automatically reload the website here and update the website and update what you see on the screen as you make and save changes to your code. So that's why this process must keep up and running. But with that, we still don't see our post content here. We still see hello world. The reason for that is that I created this component, this post component, in a separate file, but I'm not using it anywhere. It's the same as with a regular JavaScript function. If I add a function called add where I do something, even if I export that function, it's still not getting used anywhere. Instead, exporting is just the first step to make it usable outside of this file, but we then have to use the function outside of this file. And it's the same with this component function. Now, the place where we want to use our component functions is inside of JSX code of other components. So you build your complex user interfaces by combining components with each other and nesting components into each other. Now, at the moment, we have two places where we do have some JSX code in use. That's the main JSX file, where we pass some JSX code to render, and app.jsx, where I return hello world. Now, in both places, we could output our post component. But typically, when building React user interfaces, you have one root component, so one single component that's being output in main.jsx, and in this case, that would be the app component here. And then inside of that component, inside of the app component in this case, and any components used by that component, you use your other components. So the post component should be used in the JSX code of the app component. So there, instead of outputting hello world, we could output post like this. Now, in order to use it, we have to import that component function though, and we do that by using the import keyword and then post from /components/post. And the file extension should be omitted, as mentioned. But you have to specify the full relative path from app.jsx to that post.jsx file. So with that, we're importing this post component function. And even though it's a function, we're not using it like you would normally use functions by executing it, but instead we're using it like an HTML element in this JSX code that's returned by app. In this case, it's the only element that's returned. And that's the special thing about your component functions. They are standard JavaScript functions, but you can use them in JSX code. And behind the scenes, React will basically execute your component functions for you. Take a look at the HTML, the JSX code to be precise, that's returned by them, and then build the overall user interface and render it to the screen. That's what React is doing for you. So React is then generating the browser instructions that are needed to bring your HTML code to life in the browser. Now, what's really important is that in the place where you use a component function in JSX code, like we're doing it here with post or in main.jsx with app, your component functions must start with an uppercase character. It's optional in the file where you define them, but there you typically also start their names with an uppercase character. But it's absolutely required in the places where you use your components. So in app.jsx, where I import post from the post.jsx file, this name here, post, must start with an uppercase character. It should not start with a lowercase character, because in the JSX code you add to your components, elements that start with a lowercase character are considered to be default elements. So React will try to find a default HTML element with that name, which it would not find in case of post. And elements starting with an uppercase character are considered to be custom components. And in that case, React will go ahead and execute your custom component function as mentioned before. But that's why default elements like div are written like this and do not start with an uppercase character. But your own components must start with an uppercase character when using them in JSX. And that's really an important rule to memorize. But with all of that out of the way, if we save everything, we get this content on the screen. And this is now the content we defined in our own post component here. So even though it's not super fancy and definitely not interactive in any way, it is our first custom component defined and used in our React project. So we got our first custom component here, and it won't be the last component we'll work on. At the moment it doesn't have any fancy styling, but we'll add some styling soon, but I'd like to make it a bit more dynamic. And for that, I'll start by going to post.jsx, and then there, outside of the component function, though it doesn't really matter, I'll add a new constant called names, which holds an array of two possible names, Maximilian and Manuel. And I want to output one of the two names whenever this component is rendered. So basically, whenever I reload the page, and I therefore cause React to re-render the screen, I want to make sure that React picks one of the two names and outputs it on the screen, so that it's not always Maximilian, but we get some randomness on this website. Now, how could we make this work? Well, in order to make this work, we first of all must add some logic to this component function to pick a random name. So we could add a constant called chosenName. And then here, I want to call mathRandom, this built-in random method that's supported by browsers out of the way. So this is absolutely not React code. This is all built in instead. And if what I get here is greater than .5, I want to pick the first name, so names 0, otherwise names 1. So with that, I have a 50-50 chance of picking Maximilian or Manuel. Now this, as mentioned here, is standard JavaScript code. And it's important to understand that even though this will be treated as a component by React, it in the end still is a function that will be executed by React. And therefore, in this component function, you can in the end run any JavaScript code you want in that function. It's just important that in the end, your function returns some JSX code. So here I'm picking a random name, and I now want to output that name here instead of always outputting Maximilian. But how do we get this chosen name from here to here? Well, for that we'll use a special syntax that's supported by JSX and React. Instead of hard coding the value here between these paragraph tags, as we're currently doing it with Maximilian, we add opening and closing curly braces, single opening and single closing curly braces. And between those curly braces, you can put any JavaScript expression of your choice, like for example 2 + 2. If you do that and you save that, you'll see that now we get 4 as an output here. We get 4 here because when you use this special curly brace syntax in your JSX code, React will go ahead and take whatever is written inside of those curly braces and execute it, and then output the result of that expression that was executed. So in this case, we have 2 + 2, hence the result 4 is output on the screen. And we can, of course, not just perform mathematical calculations here, but instead we can also reference variables or constants. So here I can output chosen name. And instead of outputting the text chosen name now, as it would do without the curly braces, here we get the text chosen name. With those curly braces, it will instead look into that constant or variable and output the value that's stored in there. So now we'll get either Maximilian or Manuel. Right now it's Maximilian for me here, but as I reload this page, you see that it switches between these two names here. And it switches after every reload because a reload technically restarts the React application and causes all React components to be re-rendered on the screen. And even though this randomness is not a feature we'll need in a finished application, it is super important to understand how you can output dynamic values in your React applications. Because even though you might not need random values too often, you do very often need the results of calculations, of data fetched from some backend API, something we'll also do later in this course, or all kinds of other dynamic values. So this is an important piece of syntax you must keep in mind. Amazing, we get a component with some dynamic value being output as part of it, and therefore as we reload this app, the names are changing here. As mentioned before, it's probably not a feature we'll need all the time, but it's a huge step forward. However, at the moment, we're using this post component just once, here in the app component. And that is indeed often the case. You define a component, and in the entire application, you use it only once. For example, if you define a separate component for the main header of the application, the main navigation bar of your website, let's say, you typically only have one main navigation bar on the entire website, and you nonetheless might want to put that into its own component so that all the navigation logic is in one and the same place. But whilst this is a common use case, it's also very common that you want to reuse a component. And the post component is a perfect example. Why just have one post? We might have multiple posts on our website, not just one post. And indeed later we will have multiple posts. Users will be able to create multiple posts, and we want to output a grid filled with all those posts. So how can we output multiple posts based on that one component? Well, that's also quite straightforward. In this app component here, let's say we output a main element, and that's a standard HTML element supported by the browser out of the box. And you can tell that it's a standard HTML element by the fact that we start with a lowercase character and that we're not importing it from anywhere, because React supports all these standard HTML elements that are supported by browsers out of the box. So I output this main element here, and then inside this main element, I output my post like before, but I don't just do this once, but instead twice, or 3 times, or 4 times, how often you want. If you do that, you see a bunch of posts here, and if you reload, you see that they all can have different names. Sometimes you have the same name in all those posts, but you have a high chance of having some variation. We do have some Maximilians and some manuals here in my case. This also shows us one important feature of components. Even though we use the same component function multiple times, it's in the end executed multiple times by React. So it's not just executed once and the result is then reused, but instead it is executed multiple times, once per usage, so to say. That's why we have different names here, because the component function was executed multiple times by React. And that's in the end how a component can be reused. You can simply use it multiple times in your JSX code, the same component used multiple times. Now there are a couple of important aspects related to reusing components, and I want to start with one important restriction that's in the end enforced by React. When you have multiple elements side by side, as it's the case here with multiple posts, but the same would be true if we had multiple built-in components, you must make sure that they're wrapped by another component. Put in other words, in places where you use JSX code, like in the return statement here, you're only allowed to return one single element. And that element then in turn might include multiple sibling elements. But we would not be allowed to return this JSX code. As you see, I'm already getting an error here. I'm getting an error because in places where you use JSX, you must have one root JSX element, like this main element here, and then in there you can have as many sibling elements as you'd like to have, but you must have one root element. So that's an important restriction to keep in mind. Now, if there is no fitting HTML element that you want to use, you can also use empty opening and closing tags, and this syntax will actually be supported by React, but you must have one wrapping root element nonetheless. In this case, I'll use the main element though, because semantically it makes sense to wrap the main page content into that element. And since we're already talking about JSX and an important restriction enforced by React, there is another important rule you must follow. If you have elements that have no content between their opening and closing tags, as it's the case for post. You may write them as such, so opening and closing tag without content between, but you can also write it as a self-closing tag. You, however, are not allowed to write it as a void tag. You see, I'm getting an error here. So you either must add a closing tag or write it as a self-closing tag. And that's true for all elements you're using in your JSX code, no matter if we're talking about custom components or built-in components. If they have no content between the opening and closing tags, they must be self-closing, or you must have opening and closing tags. And if you have sibling elements, you must wrap them with a root element, because you can only return a single element in your component functions. So these are some important things you should keep in mind when working with components, including scenarios where you are reusing your own components. Now, when reusing components, so using one and the same component multiple times, as we're doing it with post, there's also another important React feature you must know to make those reused components more useful. Because at the moment, the component we have here, the post component, is of course still fairly static. Sure, it has this random name that's being output, but in the end here we also just have a static choice between two names. This component isn't really useful yet. Later, when we're able to create posts and store them in some database and fetch them from there, we want to be able to reuse that component with different names and different text values that are coming from a database, for example, so that are not hard-coded into the code. Well, we don't have the database part yet, we don't have any data fetching yet, but we can still start preparing this component to be more useful by adding a feature called props to it. For that, I'll first of all get rid of that randomness code because I don't need it anymore. And instead, I want to make sure that both the name and the text here can actually be configured from inside the place where this component is being used. So from inside the app component in this case here. So it would be great if we could use the post component here or anywhere else in the app, doesn't matter, and we could pass different values to that component. Just as you can pass different arguments to one and the same function if you're calling a function in your code. If you have an add function that takes two numbers and returns the sum of those two numbers, then in JavaScript you can call this function with different arguments, right? That's how JavaScript works. Now, it would be nice if we could do the same thing with components and pass different values to one and the same component. And that's where this props feature comes into play. React allows you to add your own attributes called props to your components. For example, here, an author prop, which could be Maximilian in my case here, and then maybe a text or a body prop, which could be React.js is awesome. And then the second time we use the post, we could set a different author, like manual, and give it a body like check out the full course. So now I'm using the same post component function here with different values set for author and body. This alone won't do the trick though. If we save all files, we now got no content on the screen. Because whilst we're passing data to the post component with our custom attributes here, so with that feature called props, we're not using these values inside of the post component. How would React know where the author or body information should be output if it should be output at all? Well, it doesn't. That's why we have to tell React how to treat those props. But how do we tell React? Well, again, if you have a regular function like the add function, you receive parameters, and you can work with these parameters then, A and B in this simple example. It's the same with custom components. There you receive a parameter, a single parameter though, and the value for this parameter will be passed to this function by React which should make sense because I mentioned before already that React will be executing your component functions. So here we can receive this parameter, and I'll name it props, though the name is up to you, because it will be an object using this concept called props in the React world. So this is simply a name made up by the React team that we get this props, this property collection object here as an argument in this function. So this will always be an object, what we get here. And the special thing about this object is that it will have all these custom attributes that were set on the component as property names, so as keys that we can access. So here, since I'm setting author and body on my custom component, I can access props.author and props.body on this props object that's passed into this component function automatically by React. So therefore here, in the place where I want to output the author name, I can output props author. And here where I want to output the text, I can output props.body and remove this code here. And with this simple yet important change, and by using this super important feature called props, we can save all our code files and we got our two components back, but now this time configured with different values. So it's the same component function. It's a single component function used with different configurations, with different values for these props. And thanks to us using this props feature inside of the component function, we therefore do see this different content on the screen. And that's how you make components reusable. Now, as mentioned before, not all components must be reusable, and some components might not need any props at all, but that's up to you as a developer. You can build your own components, and if you have a certain component that should be used in different places with different values, this props feature is your friend. So we got a reusable component. But one thing's missing. I guess a lot of things are still missing here, but one thing that's missing on our component here is some styling. We have some white text, and right now it's not even easy to tell where one component ends and the next one begins. I mean, we know because we created it. This name is the start of the second time we're using this component, of the second component instance therefore, but it's not obvious to see. And in general, typically you want to style your components and not just add the markup. Just as for any website, you don't just want the HTML code, you instead also want styling. Now for React, there is an endless amount of styling solutions, and I talk more about different approaches for styling components in my complete guide course. You can, for example, add inline styles by adding the style attribute to your elements. Now here the important thing to understand though is that you should not add your styles like this, so some string, some text that defines your styles, but that instead you should add a dynamic value and then pass a JavaScript object as a value. So this is not some special double curly braces syntax. Instead, it's still the same single curly braces syntax we used down there, but with the object passed as a value to the style prop. And then in that object, you set your styles, like for example, color red and text align left if you would want to make it really ugly. With that code, we would get that styling and yeah. But that's one way of styling, but just as with vanilla HTML and CSS, typically you don't want to use inline styles. Instead, it's considered better practice to put your CSS code into CSS files. And indeed, this project has one CSS file with some styles being predefined. And what you could do is add a class to your div and then, for example, give this a class of post to then set the appropriate styles in index.css. But wait a second, did I just write class name here instead of class? Yes, I did. The JSX code you write might look like HTML code, but it actually isn't. HTML code. Instead, it is a JavaScript version of HTML, and some HTML attributes have different names here. Now, to be honest, not too many, so nothing to worry about. But class is one of the most important attributes that has a different name when writing JSX code. Instead of assigning CSS classes with the class attribute, you instead use class name. Now, there are some technical reasons for that the JavaScript elements that are created under the hood have class name as a property name for setting CSS classes, but those details aren't too important to keep in mind. Instead, what is important to keep in mind is that CSS class names are added to elements with the class name prop and not with just class. But with that name being used, you can then set any class name of your choice. And if we use post here, we could, for example, add a post class here in the index.css file to give this a background color of light blue. And if we do that, we would see that background color here. Obviously still ugly, but that's another approach for assigning styles. We can set up global CSS classes here and assign their class names like this. But besides the fact that this is rather ugly, which of course is a problem that could be solved, there's another problem related to this approach. When using global class names, you could have name clashes in bigger, more complex projects. You could have multiple components that use the post class name internally, for example, and your globally defined CSS classes could then clash with each other. Put in other words, you might prefer to scope CSS styles to your different components, so that styles applied to the post component really only affect that component and can't possibly clash with other styles in other components. And React projects created with Create React App or Vite also support a solution for that problem. Instead of defining the post style like this, you can add a dedicated CSS file, which I'll name post.module.css, which should typically be located next to the JSX file, though it's not technically required, it's just a convention. What is technically required, though, is that the file name is post.module and then .css as the extension, but the .module part is important. This tells Vite or Create React App that you want to use a feature called CSS Modules here. Now, CSS Modules is in the end an approach, you could say, an approach that's implemented by projects created with Vite or Create React App, where the class names you set in your CSS files and which you then use in your HTML or JSX code are under the hood transformed to guaranteed unique class names, so that name clashes are avoided. And by using .module in the CSS file name, you tell Vite or Create React App that you want to use this CSS modules feature. Now, for this post component, I prepared some styles, which you find attached, and I just pasted them into this post.module.css file, these attached styles. And we can now use them by going back to post.jsx, and in there we now first of all have to import this CSS file. Now in main.jsx, a CSS file is imported by simply using the import keyword and then the path to the CSS file name. When using CSS modules, this syntax must change a little bit. We do still import from that path, so in this case from post.module.css, which is the relative path to that CSS file seen from that post.jsx file. But instead of just importing the file like this, we import classes or styles, the name is up to you, from that file. So you must use this import syntax. And this under the hood will then kick off that CSS class name transformation process that's supported by the project we have here. And the classes thing we get here is in the end an object where any class names used by you in the CSS file will be available as property names. And then the values for these property names will be the transformed unique class names. So we can use this classes object to set the class name on this div to classes.post. .post because in post.module.css I have a post CSS class selector. And as I just said, those classes, which are defined with class selectors in the CSS file, will be picked up by some behind-the-scenes process that's part of the project and will be converted to unique class names. And the unique class name is then yielded as a value for this post property on the classes object, which is imported from the CSS file. So we get some behind-the-scenes transformation magic going on here. And we can then also add a class name here to the author, classes.author in this case, because in my post.module.css file, I also have an author class. I also have a text class, and this text class can therefore be assigned down here. And please note that I'm always using this dynamic expression syntax with the curly braces to refer to the values stored under these properties on this class's object. And with that done, we now got this style. Still not the final look I want to have, but a great step closer to the intended final result. And if you now inspect this in the developer tools, you will see that there we have these CSS class names being assigned, and these are clearly not the class names defined in my CSS file. Instead, these are the transformed class names, because as I mentioned, that's what this CSS Modules feature does under the hood. And that's therefore another possible approach you can use for styling your components. And it is the approach I'll use in this course here, but as mentioned in my complete guide course, I also show alternatives to that. Now we're making good progress here. We got our own custom reusable component with our CSS modules based styles applied to it. Before we dive into more important React features, let's practice what we learned. And for that, I want you to build another new component, a posts list component, which in the end should render a list, an unordered list to be precise, that includes these two posts. And you should also edit the post component to use a li instead of a div. That, however, is a very simple change applied like this. The more important part is that you build that custom posts list component, which uses the unordered list to output these two posts. And you should then use the posts list component in the app component instead of these two posts here. So try doing this on your own first. Here's a short pause for you to pause the video. Thereafter, we'll implement it together. So, did you succeed? Let's implement it together. For that here, in my components folder, I'll add another new file because whilst not technically required, it is considered a good practice to put different components into different files. And I'll name this file postslist.jsx since I want to have a component named postslist in there. Again, the file names, just like the component names, are up to you, but you should try to choose names that describe the purpose of the component. And you should use this notation, where also in the file name you start with an uppercase character. And if you have a name that consists of multiple words, as it's the case here, you should actually have a single word where every sub-word, so to say, starts with another capital character, like the L in list here. So that's the posts list component. And here I'll then add a function called posts list, because you learned that components are in the end functions. And I'll export it as a default here. And then there we want to return some JSX code. And the JSX code I do want to return here is an unordered list. Now in that list, I want to output my posts here, which I already converted to list items so that we have semantically correct code. So therefore, we should grab these two posts from app.jsx and cut them there and get rid of that import since we don't need the post component in the app component anymore. And instead go to posts list and paste the two post components in there. Now, in order to use the post component in this file, though, we have to import it. So we have to import post from /post, the relative path to this post component file seen from the posts list component file. With that, we have this separate list component here, but now we have to output this list component in the app component. And doing that is rather simple as well. First, we have to import it. So import posts list from /components posts list. Here we need the components part as part of the overall path because app is not in the components folder yet. So we have to first go into that folder before we can then target the posts list component file. And here we must start with an uppercase character, as you learned. But then we can use posts list like this in our JSX code. With that saved, we have a list, as you can tell by these bullet points here. But of course, it's not really the look I'd like to have. However, this is the solution to the exercise I gave you. I want to polish this solution though by also adding a posts list.module.css file, and attached you find some styles which should be pasted into that posts list.module.css file. And with those styles added here and this posts class being defined here, we can and should then also import classes from /posts list.module.css and apply that class here as a class name, that posts class as a class name to the unordered list. And with that, this starts to look nicer here. Still not the final look I'd like to have, but we're taking some steps in the right direction. I now also want to go to index CSS and get rid of this text align center style here in the body selector. With that, I make sure that the text is left aligned, which I think looks a bit nicer. And with that, we now don't just have a nicer look, but even more importantly, we now have another custom component and we can see how these different components work together. We're using the post component multiple times, so with multiple instances, as it's called, with different configurations with help of our props here, inside the posts list component. And we're then using the posts list component in the app component, which in turn is used in main.jsx to be output there. And that's how you build React applications and how you build user interfaces by composing them from different components. So by combining these different building blocks, these different components to come up with the final intended user interface. Though this, of course, here is not the final intended user interface. Instead, we're just getting started and we're now ready to dive into another super important and for us brand new React feature. At this point, we already learned a lot about some important React features, but we're not done yet. Instead, it's now time to dive deeper into React and learn about another super important React concept, maybe the most important React concept after components and props, and that would be state. Now, what's state about? Well, let's say that in our component, we now want to add a new post component, which simply displays a form where we can enter the text and the author name of a new post that should be added. And ultimately, in the application, the website we're building, we want to be able to bring up that modal overlay, that form, which does allow us to add new posts. Now, at the moment, we're not there yet. Instead, we'll just render such a form. And as we type into this text area or this input, I want to update the text that's shown in my first post here. as a temporary step into the right direction before we then later can really use that form to add new posts to this list of posts. Now for that attached, you find a link to this new post.jsx file and the new post.module.css file. And you should add both files into your components folder. And this new post component, which basically looks like the other components we built thus far. It's a function that returns some JSX code, in this case some form markup, but only using standard HTML elements. This component should now be used next to our list of posts here. So here, maybe above that list, I want to use this new post component. But for that, we got to do two things. We have to import new post from /new post so that we make this component available in that file. And since you learned that sibling elements are not allowed, and at the moment new post would be a sibling to the unordered list, we have to add this empty element, this fragment as it's called, as a wrapper around new post and unordered list so that we fulfill that requirement React has that in our JSX code, in the place where we return or store the JSX code, we have only one root element. By the way, as a side note, inside of new post, you will see that on the label, I have this HTML4 attribute. And here we have a similar case to class name. It would normally be the for attribute, but this is not allowed in JSX code. And therefore here it's HTML4. And the good news are that with class name and HTML4, you now basically know all important deviations from the standard attribute names that you typically use all the time. But with that, we got this new post component output there. And if you save all files, you should see something like this on the screen, this form above this list of posts. And my goal now is that as I type something here, I update this text down there. So in the end, this text should go down there. And if I type a name here, that name should in the end go down there. And at the moment, that's of course not happening. But that's where this new state concept and feature can help us. So what's the idea behind state? Well, the idea is in the end that the websites you're building typically have different states in which they can be. If you have a dynamic website, so a website where things change after it was loaded, as it's the case here, where we want to change some text after it has been first rendered, if you have a website like this, then your website in the end has different states. This text here is one state, and if I enter another text here and this text down there is updated, that's a different state in which our application is in the end. And React allows you to manage such different states so that it then takes care of updating the user interface as your states change. So in order to use this state feature to update this text down here, as we type something up here, we have to do two main things. We have to register such a state, and we have to set up an event listener that tells React whenever we type here, so that we tell React when the state should be updated. And let's start with the event listener first. For that, we got this new post component here. And in this new post component, we, for example, want to listen to changes to this text area. So we want to listen to keystrokes in that text area. Now, in standard vanilla JavaScript, we would try to reach out to this text area with query selector, for example. And then we could call add event listener to add an event listener to this element. For example, the key down event listener or the change event listener, which will basically be triggered whenever the value entered into this text area changes, including cases where we paste a new value into this text area. So we might want to listen to change and then trigger some function as this change event occurs. That's how we would handle it in vanilla JavaScript. However, this is also using the imperative approach. We're telling the browser that we want to get hold of the text area and add an event listener and what should happen then. With React, we use a declarative approach instead, as you learned. And therefore, with React, if you want to add an event listener to this text area, you do that by adding a special prop. A prop that starts with on, and then the name of the event to which you want to listen. For example, on key down. The important thing to note, though, is that you do have this camel case notation where you start with a lowercase character for the on, and then the words thereafter start with uppercase characters. And for the change event, it's therefore on change. So you add this prop to the text area here, for example, to listen to the change event. Now you also must know what code should be executed when that change event occurs. And for that, we can add a new function inside of this component function. And yes, you can have functions inside of functions. That's not a React feature. That's a standard JavaScript feature instead. And this function could be called change body handler. The name of the function is up to you, but I prefer to have functions that end with handler if I plan to assign these functions to event listeners. But that's not required. Technically, this function name is entirely up to you. However, now for onChange, you set this equal to a dynamic value, and the dynamic value you want to use here is your function. However, you don't execute the function, so you don't add parentheses here. Instead, you just use the function name. Because in JavaScript, again, standard JavaScript, not React specific, functions are totally normal values, like strings or numbers or objects. Indeed, functions under the hood are objects. And therefore, you can pass functions to props just as you can pass numbers or text to props. So here we're passing the change body handler function as a value to the onChange prop. And under the hood, React will set up an event listener for the text area and set this function, the change body handler function, as a target for the event listener, so to be executed when that change event occurs. And inside of that function, we can therefore now do whatever we want to do. We'll automatically get an event object as an argument, as a parameter, and that also would be the case in vanilla JavaScript when using add event listener. There, the function which we set as a second argument also automatically gets an event argument by the browser. And the same is true here when using React. And that event parameter simply holds some useful information about the event that occurred, including the event target, which in this case is the text area, since that was the target of the change event if it occurs here. And then there we could get the value property, and then, for example, log this to the console for the moment. Now this is vanilla JavaScript code here. We get access to the target of the event, and the target is the text area element, and that turns out to have a value property which holds the value entered by the user. So with this code, we're not doing anything with state yet. We'll get to that later, but we are setting up an event listener, and we're then logging the value entered into the text area by the user who's on the website. Therefore, if you save everything and you open the developer tools and go to the console there and reload the site, if you enter something here, you see that for every keystroke, the current value is being logged here into the console. Now, if I cut this and reload and paste it in, it's also logged here because, as I said, the change event is also triggered if you paste something into this input area. So that's how you can set up event listeners. And whilst this is not directly related to this state concept, it's still kind of an important prerequisite because whilst you can use state without events, you very often want to change to a different state upon the occurrence of a certain event. Be that a value entered into an input or a button being pressed. Typically, you want to change something on the screen after a certain event occurred. And that's why it's important to understand how you can set up event listeners. And this is how you can do it with React. You define your function, then this special onProp, and then you link your event listener to the function that should be executed by passing the function as a value to the event listening prop. And you then get this event object automatically passed into this event listening function by React. Okay, so now we know how we can set up event listeners. Let's now dive into this state concept. And to get started, I simply want to output the text that's input into this text area in a new paragraph below this input in the end. We'll soon also make sure that it ends up in the post component, but for the moment, let's just output it there. To achieve this, we need to store the value somewhere and then reference that somewhere down there. And the first thing you might think about could be a variable. We could add a variable entered body, which maybe is an empty string initially. And then here, instead of console logging the entered value, we could store it as a value in entered body, like this. So we update the variable whenever this function is executed, which happens on every keystroke, as we saw. And then we could use this entered body variable down there in this paragraph. So here we can use our single curly braces and output entered body. So this variable is updated here and is then output down there. Should work, right? Well, if you save that and you type something here, nothing happens. It should be output down there because that's where I added the paragraph. And indeed, if you inspect this here, you will see that below this text area here is an empty paragraph, but it is indeed that, empty. What I type here is not being output in that paragraph. Now, why is that the case? Well, because there is something very important to understand. React executes your component functions like newPost. And it then takes the JSX code returned by those functions, so the current snapshot of the HTML content that should be output on the screen, and it does render it to the screen. But if thereafter, in your component function, you change some variable value that's being used in your JSX code, that won't be picked up by React because this JSX code is only taken once as a snapshot when this component function is executed for the first time. Indeed, if that component function would be executed by React again, it would also consider any updates to that snapshot and update the rendered user interface. But React does, by default, not randomly execute newPost again. And it does not execute newPost or any other component function again just because you changed some variable or just because you have some event listener in there. This is ignored by React. Of course, it adds the event listener and this function executes, but it does not care about whether this would theoretically change your JSX code. Instead, you have to basically create this variable in a special way using a special React feature to let React know about any changes that should cause a UI update. And for that, you have to import something from React, so from the React library, not from React DOM, but from just React. And that something is a function called useState. Now, this is a so-called React hook. React has multiple built-in functions that all start with use, as you can see here with my autocompletion. And these functions, whilst technically being standard JavaScript functions, are called React hooks. So functions in React that start with use are considered React hooks. The special thing about these hook functions is that you must execute them inside of component functions. You can't execute them in regular JavaScript functions. You can, but you'll get a warning or an error. But you must execute them in React component functions instead. And then those hook functions typically change something about that component or regarding how React behaves with that component. In case of useState, when you execute that inside of a component function, you register a new state slice, as you could say, a new state value that belongs to this component. And a state value can be anything. It can be an object, a number, an array, a string, whatever you want. Here, if we want to store the entered text, we could register a string as a state slice for this component. You set a default value for that state variable, if you want to call it like this, by passing your initial value as an argument to useState. For example, an empty string, just as I did it down there. But again, that could be anything. It can be undefined, it can be a number, it could be an object, but here it's a string. useState then returns something. It returns an array, and I'll store that array in a constant. State data is a name we could use here. Now this state data array has always exactly 2 elements, never more, never less. And the first element of state data is always the current state value. So initially that empty string, but that value can change, as you will soon see. Because that second element in that state data array is a state updating function, a function which you can execute to assign a new value to your state. Because that state value is stored somewhere in memory by React. You set an initial value, and you can then call this function, which is returned by useState, as a second element in this state data array to update that value. Now, the special thing about that is that if you call that state updating function, you don't just store a new value somewhere in memory, but React will also re-execute that function in which this state was registered. So it will call this component function again, just as it did initially when it rendered that component for the first time. And since it calls that component function again, you get the current state value, so the value which you just set with help of that state updating function as the first element here. And you get the latest JSX snapshot, and if that deviates from the previously rendered JSX snapshot, React will update the parts in the UI that need updating. And that's, by the way, also important. React will basically make a comparison between the different snapshots behind the scenes and only update the parts in the UI that must be updated so that you don't unnecessarily update the DOM, which is quite performance intensive. So that's what you get back here. Now, it's quite common to use array destructuring here, which is a default modern JavaScript feature, to store the current value in a constant and the updating function. And typically you should pick names here that describe your state, like for example the entered body, and then the updating function could be called set entered body. It's kind of a convention to name this state updating function set, and then you basically repeat your state name, just formatted as camel case. Now I'll remove that variable here, because we have a name clash otherwise. And with that we registered this state. Now to update that state, you don't try to assign a new value. That's why I also used a const here for these 2 values. Because instead you have to call this state updating function, set entered body, like this, and pass your new value as a value for this argument to set entered body. Then behind the scenes, the new state value is stored, and this component function is executed again, and entered body will then hold that new value. That's why it may be a constant, because it's always a brand new constant, because it's always a brand new function execution in the end when you update the state. So now we can use this entered body state here in this paragraph to output the new state value. But this time, because we're using this state feature provided by React with help of the useState hook, this will all work. And if I now save everything again, you will see that as I type something here, it updates down there below the text input. So this works now. And with every keystroke, this gets updated, as you can see. Now that's React's state feature in action. So that's how we can use state. And the special thing really is that when you update your state, the component function gets executed again, and therefore the latest JSX snapshot gets used by React, gets compared to the previous snapshot, and the UI is updated where needed. Now here, however, the goal was to basically get this text into this first post component. And of course, that's not happening right now. One problem we're facing here is that this state is inside the new post component. That's great, but we don't need it there. Instead, we need it in the posts list component so that we can set this entered text as a value for this body. Now, how do we get the state from new post to posts list? Well, an obvious solution would be to import useState from React in the posts list component and register the state there. We could have the entered body here with help of useState. And this should use object destructuring here to get the entered body and the set entered body state updating function. Now we have the state in the component where we need it, and we could set this body to the value that's currently stored in entered body so that our current state value is output down there. That's amazing and great, and theoretically that's a good approach, but now we have the state in the right place, but the event is in a different component. So how can we solve this puzzle? We either have the state or the event in the wrong component. Well, what we have to do here, and what we already started doing, is something that's called lifting the state up. If you have state that's manipulated in component A, but needed in component B, you should lift the state up to a component that has access to both components that need the state. So in this case, it's the posts list component that needs the state to pass it to post as a value for the body prop, and it's also the posts list component that has access to the new post component, which is the place where the state should be manipulated. Now what we can do in this case is we can get rid of the state here in new post and get rid of the event handler function and the useState import as well. And we could now simply use this props feature, so this props object, which we get by React automatically, to set this onChange event listener prop equal to, for example, props.onBodyChange. Now this prop name is up to you because you can set any props you want on your own components. With that prop being set like this on the onChange prop of text area, we can go to posts list, and on new post, we can now add the onBodyChange prop here to the new post component. And as a value, we can now again pass in a function that should be called when the text area changes. So when the change event occurs on the text area. In this case, for example, the body change handler, where we automatically get the event object as before, and where we then call set entered body equal to event.target.value, and it's then the body change handler function which is passed as a value to onBodyChange, to this prop. Now this might be confusing at first, but what I'm doing here is I'm passing this body change handler function to onBodyChange. So we're not executing it here. We have no parentheses. Instead, I'm using this function, body change handler, as a value that's passed to the onBodyChange prop. Now in the new post component, I'm then in the end forwarding that value that's received on the onBodyChange prop as a value to the onChangeProp of text area. So we simply pass that function, that bodyChangeHandler function, through the newPost component with help of the onBodyChangeProp to the text area component. And this should all be quite a bit less confusing if you keep in mind that functions can be used just like any other kind of value in JavaScript. So therefore, in the end here, we wire up this bodyChangeHandler function to this change event on text area. That's why we also still get this event object. And with that, we can now update the state in the component where we need it, whilst still setting the listener in the component where the event occurs. And of course, we can also do that with the author input. There we can add the default onChangeProp to add a change event listener to that input as well. And for example, expect to get a function value on the onAuthor change prop. Again, this prop name is up to you because it's your component. But with this prop chosen here, instead of newPost, we now have to use the same prop name here on the newPost component in posts list, and then copy that bodyChangeHandler function and name this copy author change handler, for example, to then pass this author change handler function as a value to the onAuthor change prop. And then again, that's picked up and used as a value for the onChangeProp inside of that newPost component. Now we just need to register a second state slice for that author name, and that is something you can do. You're not limited to one single state per component. Instead, you can have as many state values as you need. So here we can simply call useState again to register a second state value for this component. And this also is an empty string initially, but then we get back two values again, or one value, one array with two elements to be precise. That's my entered author and then my updating function, which could be called setEnteredAuthor. And whenever any of these two states changes, this postslist component function will be executed again. In that case, the entire JSX code down there is evaluated again, which means that any nested component functions are also executed again. And that leads to precisely the behavior we want, because that means that this post, where we pass our updated state values as values for its props to that post component function, this post component function will also be executed again if posts list executes again. And therefore, these updated values, which we pass as values to props to this component, will be reflected in the JSX code of that component, and hence the UI will be updated accordingly as well. So that's how UI updates work with help of React and state. So therefore here I now want to pass my entered author as a value for the author prop for this first post component. And then here in author change handler, I call setEnteredAuthor and pass event target value as a value. With that done, we just have to go to newPost and get rid of this paragraph with entered body in there, because we no longer have the entered body state in that component. And if you then save everything, you see that this component is empty by default, which should make sense because our default states for entered body and entered author are empty strings. But as soon as I start typing something here into these input fields, you see that the component down there gets updated dynamically with every keystroke because of state and because we lifted state up into a place where we can update and use it. Let's continue diving deeper into React. We get this form here, this input form, and it looks decent, but I'd like to open it as a modal overlay. So some overlay that's above the rest of the content on this page. And in the end, achieving this look is a pure CSS thing. Now, what we could do is we could edit the styles of this new post component such that it has this modal look. You can add a backdrop behind the form, so some background, so that it looks like an overlay. But I'd rather take a different route. In the end, I want to make sure that in the place where I use this new post component, and I just pressed the auto format shortcut here to put these props into separate lines, which is still valid code, but easier to read. But I'd like to take a route where I have a new modal component, which doesn't exist yet, which can be wrapped around new post to give that new post that modal overlay look. Again, this modal component is a component we have yet to add, but I'd like to have a component that can be used like this. Now, the idea behind that is simply that on more complex websites, chances are high that you have all kinds of content that should have that overlay look. Not just this new post form, but maybe also some warning dialogues, anything like that. So it would be nice to have such a wrapper, and being able to wrap content with components of yours is indeed another core React concept. You can really only compose flexible, powerful user interfaces if you're able to also wrap components with other components to apply some extra styles to them, for example. And therefore, to achieve this here, I'll add a new component called modal. A modal.jsx file is therefore added. And attached you find a link to a modal.module.css file, which you should add, which simply comes with some styles that will help us achieve that overlay look. And then inside of modal.jsx, we can create a modal function and export that as a default. And then in there, I want to return a fragment, so this empty tag, where I have a div without any content inside, and then a dialog element that will hold the actual modal content. And this div will be used to render a background, a backdrop as it's also often called, for this modal. Now we should import some CSS classes here from modal.module.css, and then assign one class here to this div, and that would be the backdrop class. And to the dialog, we should also add a class, and that's the modal class. And backdrop and modal are both CSS classes defined in this CSS file. Now with that, we have a modal component, but if we try to use it as a wrapper around new post, so inside of posts list, if I go there and I then try to import this modal component, which we just added, from /modal, like this, and I then use it as a wrapper with the opening and closing tag around new post, you will see that it doesn't really look the way it should. It looks like the backdrop is visible. We have this gray background, this transparent black background everywhere, but the form and the modal is nowhere to be seen. The reason for that is that if you wrap content, no matter if it's a component or some default built-in elements, if you wrap content with another custom component, by default, React does not know where to put that wrapped content inside the wrapping component, so inside the modal component in this case. You have to tell React where that wrapped content should go. And you do tell React with another special prop, so with the props object. And that special prop is the children prop. By the way, instead of always using props dot, you can also use object destructuring here to directly get access to a specific value, so to a specific property of that props object. This is not only possible when using this special children prop, but it works with all props. So for the post component, you could, for example, also use object destructuring to get the author and the body, and then save yourself the props dot call down there. But that's just a side note. So this is just a more concise way of getting access to your props. What's new and important here is this special children prop. Thus far, we always added our own props. A post, for example, has our own author and body prop, and these names were up to you. Now for children, it's different. That's a reserved prop name because children always refers to the content that's passed between the opening and closing tags of your custom component. So here, this content, the new post component in this case, that's the value that will be received on the children prop in this modal component function. And we then output it down there so that we tell React that in the end here, it should output the content that's passed between the modal opening and closing tags. Now with that change applied, we just have to adjust the styling of this new post component here a little bit and get rid of this box shadow, border radius and margin. And also back in the modal component, add the special open prop on dialog, just like that. The value theoretically is true, but if you set true as a value for a prop, you can also omit it and just add the prop name, and then true will be used as a default value. And this open prop is simply required by the default dialog element to make sure it's visible. And with all these steps taken, you get that overlay with that form, and it's above the other content. So that's great. That's now the children prop in action, helping us create a component that can be used as a wrapper around another component. Now, whilst it's nice that we have this overlay here, it's not that nice that we can't get rid of it. I can type something here, and you see that it gets updated in the background. But of course, it would be great if we could close this modal somehow. For example, by clicking on that backdrop, on that transparent black background. So how could we achieve this behavior? Well, in the end, again, with help of state. You could say one state should be that the modal is visible, and another state should be that it's not visible. And then, for example, by clicking on that background, we want to update the state and switch it from is visible to is not visible. And then we want to display this entire modal conditionally based on that state. So it's in the end a three-step process. Register a new state, add an event listener to this backdrop, and then use that state to show or not show this modal. So to implement this, I'm back here in posts list JSX, and I'll zoom out a bit since the code keeps on growing. And there we now don't just want to manage these two values that can be submitted or entered through that form, but I instead now also want to add an additional state slice here with useState. And the position does not matter if it's the first, the second, or the last state. This does not matter. But here the default value should, for example, be true, because here I won't manage some text as a state value, but instead the modal is visible state. The name is up to you, but you should try to describe what's controlled by that state. And here I want to control the modal visibility. So I'll name it modal is visible, and the updating function could be called set modal is visible. And by default here it's true, so that we start with the modal being visible. Of course, this alone doesn't do much. We now also need to add some code to change this if we click on this background here. Now to achieve this, we can go to the modal component, because here we got that background. It's this div here. And there we can add the onClick event listener. Click is another default event, and onClick is therefore a prop we can add to set up a listener to the click event on that div. And the function that should be executed should now not be defined here in this modal, but again in posts list. So again, we're lifting the state up. Here we can add a new function, show modal handler, for example, or in our case, actually the hide modal handler, because that's what we want to do if the backdrop is clicked. And here we can call set modal is visible and set it to false as a new state value. Now we have to pass this function as a value to the modal component here. So here we could add a prop called onClose. It's your component, so the prop name is up to you. And pass the hide modal handler as a value to onClose. Again, without parentheses, passing the function itself as a value rather than the return value of that function, which is what we would pass if we would have parentheses here. So we pass the function itself. And since I named the prop onClose here in the modal component, we can now also destructure this onClose prop here and set it as a value to onClick, so that this function which we receive on the onClose prop is set as a value for the onClick prop, hence wiring this click listener up to this hide modal handler function in the end. Now with that, we have a way of updating the state, but right now we still wouldn't see any effect on the screen because we're not doing anything with that modal is visible state. We're updating it, but we're not using it thereafter. And that's the last step. Now we want to render this modal conditionally based on our state. So the goal is to only render this piece of code here, this JSX code, if modal is visible is true. Now how can we achieve this? Again, with a dynamic value, so with single curly braces. But now we don't just want to output modal is visible. We don't just want to output true or false, but instead we want to control what's being shown on the screen. We could achieve this with a ternary expression. If that's true, and for that we can also just check modal is visible, we want to output this content. And indeed you can cut and paste that content here after the question mark. And then add a colon here, since I'm writing a ternary expression, where we also define what should be rendered if this is false. And that could be null. Null is something you can output as part of your JSX code, and it will simply lead to nothing being rendered here. Alternatively, you could also set this to false, and this would also render nothing. If I now save this, you see by default, this is open, which should make sense because our default state value is true for modal is visible. But if I click on this backdrop, it disappears. And it disappears because I set the state to false. That's what we do here. And thanks to this ternary expression, it's then this else case that becomes active. And if you output false or null here, nothing gets displayed on the screen in this place in your JSX code. The other parts, like this list, are still being output, but this content, to be precise, is now rendered conditionally with help of that ternary expression. Now, there are other approaches as well. We could, for example, add a variable, modal content, and by default set that to nothing, so to undefined, and then check if modal is visible is true, and in that case set modal content to this JSX code. You can store JSX code in variables as well. You cannot just return it in functions. You can use it anywhere where a value is wanted. And then down here in the JSX code we do return, we could now just refer to modal content. And this would now either be nothing, undefined, which also leads to nothing being output on the screen, or it's this content. Now we are using a variable here, but we'll see the updated content nonetheless because we are using a state value, which is updated with our state updating function here in the posts list component. So this variable will only receive a new value if the state was updated with that state updating function, and therefore this component function was executed again. Hence we'll see the updated JSX snapshot being reflected on the screen. So with that code, if I reload the page, it will still close if I click on the backdrop. And one last alternative which I want to show you, though this here is a great approach since it's also quite readable, is that you go back here in your JSX code And instead of writing a ternary expression, you use the modal is visible state value again, and then the logical AND operator here to then define the content that should be output if modal is visible is truthy, so if it's true in this case. Due to the way JavaScript works, it will now output this content only if this value here is truthy, if it's true, and otherwise it will output nothing. Or to be precise, it will output the falsy value, false in this case, and that, as you learned, will lead to nothing showing up on the screen. So here we're using standard JavaScript to render nothing or the modal. So that's another approach of making sure that we can hide it. And no matter which approach you prefer, all three approaches are fine, but that's how you can render content conditionally. So at this point, we can close the modal if we click the backdrop, but we can't open it again. Now to open it again, I want to add a header component above my list here, which gives me a button that allows me to open this modal. Now I prepared such a component in advance since it won't include any new features we haven't learned about yet. Attached you find a main header.jsx file and a link to the main header.module.css file. And the main header.jsx file simply defines a main header function where I got some JSX code. Now one noteworthy new thing is in there though. I'm importing some icon components from a third-party library. And at the moment, this library isn't downloaded into this project here. To make sure these icons are available here and this import command here works, you should quit your development server by pressing Ctrl+C, and you should then run npm install react-icons to install this React icons library into this project. This makes it available as part of your code base, and importing these icon components will then work. And thereafter you can run npm run dev again to bring up that development server again, which you must have up and running as long as you're working on your code. So with that, we got that main header component, and now this main header component should be rendered above this posts list. For that, I'll actually go into the app.jsx file, and in there, I'll import main header from components main header, and then return a fragment, which wraps this main section and posts list, and render the main header here above the main section. With that, we got this main header here, but this button of course doesn't work yet. To make it work, this button now also needs to set this state that shows or hides the modal. The modal is visible state. However, that state is in the posts list component. But you learned how this problem can be fixed. You can lift the state up. We can cut this state from posts list and move it into the app component. And there we then also must import useState from React to make that useState hook available there. We then also must cut the hide modal handler function and move that to app, and also already add a new function called show modal handler, which does the opposite of hide modal handler. It simply sets modal is visible to true again. And now we just need to make sure that the information, whether the modal should be visible or not, is available in the posts list component. Now to make it available there, we can use props again. We can add a new prop. Is posting could be the name. You could also stick to modal is visible alternatively. But here I'll use is posting as a prop name. And that should be true or false, and I'll use it down there in my conditional rendering code. So if this is true, the modal should be displayed, because if I am posting, I'm working on a new post, so then this form should be displayed. And if it's false, it should not be displayed. And in the app component, we can now set this new is posting prop on posts list and simply forward our modal is visible value. So set the value of this state as a value for this prop. And with that, we're passing the information whether the modal should be visible or not to posts list. Of course, now we also must make sure that we can talk into the opposite direction. So if the modal is closed, we wanna trigger hide modal handler if the backdrop is clicked, for example. And in the main header, if the button is clicked, I wanna show the modal again. Now here in main header, I already do expect to get a onCreatePost prop, which I forward to onClick on that button. So here I want to have a pointer at that function that should make the modal visible. So therefore back in app.jsx, we can add the onCreatePost prop to main header. We can set that prop and set it to show modal handler, so to this function. So that this function is passed as a value to onCreatePost. And on the posts list component, we could add another prop called onStopPosting. And here pass the hide modal handler function as a value. Now we just have to make sure that we use this onStopPosting function in posts list. And therefore there, again, we can accept it as a new prop. And then here, for modal, for the onClose prop, we now pass the onStopPosting value to the modal component. So that in the end, the onClose prop of the modal component receives this hide modal handler function. And passing these different functions across multiple levels of components and passing these different state values around, of course, can be confusing at first. So therefore, it's just important to keep in mind that in the end, we're just passing values around so that in the different components, we can use exactly the values that should be used there. By the way, the fact that my custom props here that take functions as values, like onCreatePost, are called onCreatePost, is just a convention I'm following. I could also just name it CreatePost and update the name here in main header, of course. And that would work as well. However, it's a common convention to start with on in your prop name if that prop is receiving a function as a value. To, in the end, make it clear that this prop won't work with any other value, and in the end will typically link that function that is received as a value to some event listener further down in your JSX component code. However, now with all these changes made, if you save all your code, we can close that modal and we can also open it again. So that's now working. And therefore now back in app.jsx, we can also switch the default for modal is visible from true to false to make sure that initially, if we reload this page, no modal is visible, but if we click that post, we see it. And then there we can still edit and add our text as we need to and update this first post. And therefore that's yet another huge step forward with more state passing across different components. And with that, we're now ready to dive even deeper into React and make sure that we're now not just updating this first post here, but that instead we can really submit that form. And once we do so, we actually edit this list of posts so that we finally can start adding new posts instead of just editing the first one. So let's now make sure that we actually have a form where we have a submit button and maybe also a cancel button to cancel editing and close the modal, but that we have a submit button which, when pressed, adds a new post, and our list or our grid of posts then keeps on growing as we add more posts. To achieve this, back in the new post component, we first of all have to add some buttons there. For this, here at the end of the form, we can add a new paragraph, which should receive a class name of classes.actions, since I prepared a class named actions in the CSS file, which then will style these buttons accordingly. Now, in this newly added paragraph, we should add two buttons. Now, the second button will have a caption of submit. The first button will have a caption of cancel. However, by default, if you add buttons to a form, if they are pressed, they will submit that form. This means that a submit event will be generated, and also that by default, the browser will generate and send an HTTP request to the server that's serving the website. Now we don't want that and will prevent it therefore, because we want to handle the input with our client-side code instead, with React instead, not with server-side code here. But besides that, I also want to make sure that not both buttons submit the form. Instead, only the submit button should do so, not the cancel button. To make sure that the cancel button does not trigger form submission, we can and should give it a type attribute which we set to button. The alternative, which we can set on the submit button, is type submit, but this is not required since that is the default anyways. Now this button here will now not submit the form when clicked. Instead, it should close the form, and to ensure that it does, I'll accept a new prop here, and I'll actually also use object destructuring here to get my on body change and on author change prop, so that we can get rid of props dot here in these two places. But I'll now also accept a new prop, as mentioned, which could be named on cancel. Name is up to you, but I do expect to get a function on this prop because I want to connect it to the on click prop here, so that in the end, an event listener is set up triggering the function which will be received on the onCancel prop. Now this onCancel prop therefore must be set here on the new post component, and it should be set to a function that will close that modal. Now for that we have the onStopPosting prop, which we're already receiving here on posts list, which, if you remember, will in the end trigger hide modal handler, which is exactly what should get triggered, so I can reuse the onStopPosting prop here and set it as a value for the onCancel prop. So with that, if we save everything and we open our modal, we now got these buttons. And if I click cancel, the modal closes. But now let's make sure that we can also submit that form. So how can we now handle form submission, and what should happen when the form is submitted? Well, in that case, I of course also want to close the modal, but I also want to get the two values that were entered and in the end add them to my list of posts. And the list of posts should then also be output dynamically instead of having these two pseudo hard-coded posts here. So let's handle this step by step. First of all, in the new post component on this form element, we should add an event listener, a new prop called onSubmit to listen to the default submit event, which is a default event supported by the browser out of the box. Now we need a function that should be executed when that submit event occurs. And I want to have that function in the place where I also collect the values that are entered. Now in my case here, these values are managed in posts list, but actually we don't need to do that there anymore. I'll instead bring them back down to new post, to the new post component. So I bring my state slices back there. And therefore here we now import useState from React again, and I don't need these state slices in the parent component, in the posts list component anymore, because I don't want to use them for setting my post author and body here anymore. Instead, I'll get rid of that post for the moment, and soon I want to dynamically render a list of posts here anyways. So therefore we can also get rid, and we must get rid of on body change and on author change on the new post component. And to clean things up, I'll also get rid of that code here. And posts list therefore is now much leaner. But in the new post component, I now wanna call body change handler again if my text area changes. So I will set body change handler as a value for the on change prop here on text area. And for input on change, I'll set this to author change handler, so that in the end, these entered values are managed as state in the new post component again. And these two props, on body change and on author change, are not needed here anymore. Now we also must add a function that should be triggered when the form is submitted. So I'll add a new function here submit handler could be the name. And this function is passed as a value to onSubmit. Now here, just as with the other event handler functions, we get an event object automatically, since it's set to onSubmit, so to this default submit event. And now we gotta do one important thing here for this submit event. Because as I mentioned before, when a form is submitted, this submit event will be triggered and the browser will automatically generate and send an HTTP request. And we don't want that here, because sending an HTTP request to the server that's serving this React app would in the end lead to the page being reloaded, and we have no server-side code here that would handle that request. React is a frontend library running in the browser, not on the server. It can't handle that request. Therefore, we have to use this event object and call the built-in prevent default method written like this. This prevents the browser default of generating and sending an HTTP request. With that done, we can then thereafter collect and group the entered body and entered author values into a post data object, for example. A default JavaScript object where I add a body property, which can be set to entered body, and an author property, which can be set to entered author. We could also add some client-side validation here and update some state to show an error message if invalid data was entered, but whilst that is something we do in the complete guide, it's not something we'll do here in this crash course. Instead, we'll just assume that the provided data is valid and will rely on the default browser validation added with help of the required attribute. And we therefore now got our post data here. And now that post data in the end should be added to a list of posts, which should then actually be rendered as a list of post components onto the screen. And that's what we'll do next. This is, however, how we can handle form submission. And we can see that it works if we then console log our post data here like this in the submit handler. If you save all your code and you make sure that the modal is open, and you open the developer tools thereafter, you can enter something there, and as you click submit, you get this object here with those entered values. So that's working. And now I just want to make sure that this modal gets closed if I submit this. So therefore thereafter, I'll call onCancel as a function, like this. Keep in mind, onCancel is this prop which receives a function as a value, and therefore we can execute it as a function here, hence executing that function that is received as a value on the onCancel prop. And that function simply turns out to be that hide modal handler function. So that's the function we're in the end executing here. So with that, if we try this again and click submit, now the modal closes. So let's now make sure we output that list of posts. So we're gathering that post data. How can we now add that as a post to a list of posts that should then be output dynamically here instead of outputting this hard-coded post here? Well, in the end, again by using what we already know, plus 2 new concepts or features. In the end, we have to get this post data from the new post component to the posts list component. And there we then should manage some state, which in the end manages a list of posts. And whenever that list changes, we want to update the list we're outputting down there. Therefore, we can use state here and import useState from React in the posts list component and pass an empty array as an initial value. And that then should be our posts array with a setPosts state updating function. So the idea is that here we manage a list of posts, and that list should be edited whenever we submit a new post. So therefore, we also must add a function here in posts list, which adds a new post. And that could be the addPostHandler function, and I name it addPostHandler because in the end, again, it should be triggered whenever the form is submitted in the end. Now here we could expect to get some post data. And then we want to update our posts state with set posts here. And in the end, pass a new post object to this array. Now for that, what we could do is pass a new array as a new state value to set posts, and then add post data as a new value to that array. And to make sure that any potentially existing posts aren't lost, we could use this spread operator, a default operator built into JavaScript, to spread our existing posts into this new array of posts, so that we add this new post as the first element in this array, and the existing posts come thereafter. This is not optimal, but it will work. So now we just have to make sure that the add post handler is executed as the form is submitted. For that, we can pass this add post handler function with help of a prop to the new post component. So we could add a prop called onAddPost and set the value of that prop to the add post handler function we just added. And inside the new post component, we can now use the onAddPost prop, again using the same mechanism we've used over and over again, to accept that prop here and destructure it from this props object. And in submit handler, before calling onCancel, we can now call onAddPost, since this again is a prop yielding a function, and passing the post data to this function. And this function that is executed in the end is this addPost handler function. So this will now add this post to this array of posts. But as I mentioned, this code here isn't ideal, because there is a rule. If you update state and that new state is based on that previous state value, as it's the case here, where the new state is based on the existing posts, you should actually pass a function to set posts. For example, an arrow function. And this function here will be called automatically by React whenever you call set posts. And this function will automatically receive the current state snapshot, so the existing posts, and you should then return the new state value, where you could, for example, again, add your post data and spread the existing posts. Now this looks very similar to what we had before, but it's the technically better way of updating your state if it depends on the previous state snapshot. The reason for that is that internally, React does actually not execute your state updating functions instantly. At least it's not guaranteed that it will do so, but it schedules those state updates. And in case you have multiple state updates after each other, you could potentially update your state based on some old state or anything like that. And therefore, this way is a way of making sure that React ensures that you get the latest correct state for this state update, even if you have multiple pending state updates. So therefore, it's this simple rule. If the new state depends on the old state, then you should use this function form for updating the state. You get the old state automatically, you can use it, and you should return the new state then as a value, and you can use the old state if you need to, as it's the case here. And this does not just apply if your state is an array, but whenever your new state depends on the old state. And with that, we're managing this list of posts. How can we now output it down there and render one post component per post item in this array? Well, to output this post component for our different array items, we have to add this dynamic expression here again, because we want to refer to our posts state here. And now in the end, we want to transform our array of post objects into an array of JSX elements, one post element per post object. Because if you output an array of JSX elements in your code, for example, here some dummy paragraphs, that will actually be rendered to the screen, as you can see here. So you can output an array of JSX elements in your JSX code with these single curly braces. So therefore, we could output the posts array, but that would be an array of pure JavaScript objects, not of JSX elements. But in the end, you must output JSX elements down there. Therefore, you can call the built-in map method on this posts array. This method exists on all JavaScript arrays. And this method takes a function which is executed by the browser for every item in this array, receiving that item, and then you return the value to which this item should be mapped. So map returns a new array where every item in that old array was transformed into a new item, into a new value. And here I want to transform every post in my posts array to a post JSX element. That's some code you can write here, and in the end, this will yield us an array full of JSX elements. So this function here is executed for every post in posts, and therefore now we just have to set the author here to post.author and the body to post.body. And we can access .author and .body on the post object in the posts array because the post data object, which we add to this array, comes from onAddPost in the end, since that's the prop receiving the addPost handler function. And this comes from newPost, and there it's this post data object we have here, which we pass in the end to addPost handler. So it's this object with this structure that's added to the posts array. And here we have a body and an author field, and therefore here we can access .author and .body. And with that, if we save that, we got no posts initially, but I can add a new post like this, click submit, and it shows up here. Just like this. So that's how you can dynamically output lists of items. However, if you open the developer tools, you'll notice that we get a warning here that each list item should have a unique key prop. That's a requirement by React, which in the end ensures that React is able to render and update lists efficiently. I talk more about that in my complete guide course. In the end, whenever you output a list like this, so if you map an array to an array of JSX elements, you should add the special key prop to the JSX element, which is not a prop you must accept or use in your component. The post component doesn't use any key prop here, but you can still add it to every JSX element because it's a special built-in prop supported by React. And this prop should receive a value which is guaranteed to be unique for every post. Typically, that should be some unique ID. Here, we could use the post body, which in theory could occur twice for two different posts, but which is good enough for this demo. And with this key prop added and set to post.body, you also see that if I reload and test this again, the warning does not show up again. So that's how we can output a list of posts with help of this map function and with help of managing our posts with state. Now, to finish this first version of this app, I just want to make sure that I also show a message if we have no posts yet. And in the end, that means that in my posts list component, where I output that list of posts, I just have to render this unordered list conditionally with a dynamic expression where I check if posts.length is greater than 0, which means it is an array that has at least one post. And if that's the case, I then want to output that unordered list using this conditional rendering approach you learned about before. And then I add another expression where I check if posts.length is equal to 0. So if I have no posts, and in that case, I'll render a div where I'll just add some quick and dirty inline styles, where I set text align to center with this syntax and color to white. And inside of that div, then a h2 element where I say there are no posts yet. And below that, a paragraph where we could say start adding some, like this. Text align is written like this instead of text dash align because this would be an invalid JavaScript property name. Therefore, you have to use camel case notation. And with that, we now got this fallback text. But as soon as I add a new post, this disappears and my list of posts shows up instead. Like that. So that's working. And with that, we now learned about a lot of key concepts that you must know if you want to work with React. But it's not all we can do with React. Instead, it's now time to dive into more advanced features. By now, we learned a lot about the most essential React features you must know to get started building reactive user interfaces with React. But the demo app, the demo website we built thus far, of course, only works in the browser. There it works absolutely fine, but if we add posts and we then reload this site, all the data is lost because at the moment it's only stored in memory whilst this React app, this JavaScript app in the end, is running. And React, and that's really important, is a frontend JavaScript library. You use it to build a user interface. It powers your web user interface with JavaScript in the end, and it therefore executes in the browser. Indeed, what we're building with React.js in most cases is a so-called single-page application. An application, a website, where we in the end have only one single HTML file, this index.html file here, and then everything that happens on the screen is powered by JavaScript. So if we open a modal here, that's not a new page, not a new HTML file that's being downloaded or opened. Instead, it's the existing page being edited by JavaScript, the DOM being edited by JavaScript. If I view this page source here, I just see the basically empty HTML file, this index.html file that was downloaded initially. But in this file, we have this script import, which in the end imports our JavaScript, our React application, and it's that application that then edits the DOM so that the actually rendered DOM has far more elements than the initial HTML file. So we use React to build this interactive frontend, and in the end, what we're building is a single-page application. But it would, of course, be nice if the posts that we create here would not just be stored locally in memory so that they're lost whenever we reload this, and so that also no other users can see them, but if we instead had some backend to which we can send requests and from which we get back responses, where the data could then be stored in an actual database. So with backend, I mean a separate web application, a web API, a REST API, for example, running on some server, so not in the browser of our users, but on some server owned by us, for example. And that backend API, that REST API, could be built with any language or framework of your choice, not necessarily with JavaScript, and typically not with React, since React is not really a backend library. I'm saying not really because there are frameworks like Next.js or Remix, on which I also got courses, that build up on top of React and allow you to blend backend code into your React app, but React itself is not a backend library. Instead, it really focuses on allowing you to build interactive user interfaces, as you learned. But we still might want to be able to store data on some backend, in some database, for example, and for that we need such a backend API, either a third-party API or an API built by us. And then that API, that backend service, could interact with files or with databases or anything like that, so that our front-end application, the React app, then can send HTTP requests to that backend so that some data gets stored there, or so that we fetch some data from the backend, which is then returned to the front-end through an HTTP response. That is something we might want for this demo app here. And for that reason, attached, you find a link to a dummy backend project, a dummy REST API in the end, built with Node and Express.js, so no React code here. And you don't need to know Node or Express to follow along, because this backend API is already finished. And what I'm doing here in this backend API is I'm storing some data in a posts.json file. We could also use a database, but that would simply require some extra setup. So for this demo, I'm just using this file. We're storing some data there and we're fetching some data from there. And I provide various REST API endpoints that allow us to get a single post or create a new post. And then I got all the logic for doing those tasks in here in this API. And therefore, if we start this backend server locally on our machine for this demo, we can add code to this frontend application, to this React application, for it to reach out to this backend. And of course, if you would deploy this, you would have two different servers with two different domains. Here, we can run both on our local machine and simply use different ports to simulate different servers and domains. This backend application listens on port 8080. And we can start it by first of all running npm install to install all dependencies that are required, and then running npm start to start that node server. And just as the front-end development server, you should keep that server up and running as long as you want to be able to send requests to this backend. So now with that backend up and running, we can go back to the front end and add some code to it that allows us to send requests to that backend, to create new posts, and of course, to fetch posts as well. So how can we send requests from inside our React application to a backend? Well, let's start with creating new posts. For that, we got this new post component, and there at the moment, I have this submit handler where I in the end call on add post and pass the collected post data to the parent component of new post. In this case, that's the post list component. There I'm using the new post component, and on add post, we're executing this add post handler where at the moment we're updating this local post's state. Well, we definitely still want that local post's state because we still want to render some posts, but we also want to send that data to the backend. And in that backend code, just as a side note, this API route should be hit, a post request should be sent to this path on the backend, and there this post will be stored in a file in this posts.json file, enriched with an extra pseudo-unique ID. But that's just a side note. So that's the path to which a request should be sent. And to do that, we can use the fetch API. The fetch function is available in browsers out of the box. It's not a React feature, and fetch can be used to send HTTP requests. And unlike the name suggests, you cannot just use it to fetch data, but also to send data. It's a bit confusing, but that's what you can do with that fetch function. Now, fetch takes the URL to which you want to send a request, and in my case, that's localhost 8080. Localhost because this backend runs locally on our machine, and 8080, as mentioned, is the port on which we listen on this backend server. So we send a request to this URL or to this domain, and then there specifically we want to target the /posts path here, because as I just mentioned, it's this /posts path here where we expect a post request if we want to store a new post in this file. Therefore, we also have to configure this request, because by default fetch sends a get request, and we can now pass an object as a second argument to fetch to set the method to post, to turn this into a post request, and to then also add a body, so the data that should be attached to this outgoing request. And here the data I do want to send is my post data, of course, the data we're getting here. But we have to convert this to JSON, so to the JSON format, which we can do with the built-in JSON object and the stringify method. With that, we turn that data into JSON, as we must do. And then, last but not least, we should add some headers to this outgoing request by setting an object on this headers property. And here I want to add the content type header and set this to application JSON. And that's how we could send such a post request with our post data to the right path on this dummy backend. Now fetch will then send this request, hit this API route here, this API resource, and then ultimately it will return a response. Now for the moment, I'm not really interested in the response here, and therefore we can just save this. And if we do so, and I add a new post, test, max, it still appears locally because I still update my posts as I did before, but if we switch to the backend here, we should see that in posts.json, we also got the post here. So it was indeed received on the backend and stored there. And that's generally how we can send a request from our frontend to the backend. Nothing special about that here. It's the standard fetch function, and it does what we would expect. But of course, we now also want to fetch data. We want to make sure that if we reload this page or if we visit it for the first time, we fetch the available posts from the backend. And here things become a bit more tricky. So how can we fetch posts when we first visit or reload this page? Well, for that you could of course say that you go to posts list, because that's where we need the posts. And we also send a fetch request here. We target the same URL as before, because if we take a look at the backend, we see that in the end a GET request to /posts gives us all our posts. And then here we already send a GET request, because as mentioned, that's the default for the fetch function. So we don't need to configure this request. And now what? Well, now in the end, I want to make sure that we update our posts here whenever we got a response. Well, for that, you could try to use async await like this, but this is not really supported. Your component functions must return JSX code or some other values, but promises should not be returned, at least for this standard component here, without using any extra framework on top of React or anything like that. So promises may not be returned, and since adding async in front of a function always ensures that this function returns a promise, because any data returned by the function gets wrapped into a promise, we must not use async here, and we therefore can't use await here. But of course, we could use the standard old school way of handling the response and add the then method here to get our response, and then return response.json to unpack the data from the response, because that's how you do it with this response. There is a JSON method, which then ultimately gives you the data that was sent back from the server. And that data that's sent back is an object with a posts key that holds all the fetched posts. So we could add another then block here and then access data.posts. And there, to be precise, we might want to call setPosts and set our posts to data.posts. But we should not do that. You should not save that. You should not write this code. Because if you would write this code, it theoretically would update the state with the new posts, but it would cause an infinite loop. And why would it do that? Well, simply because whenever you update your state, as you learned, your component function gets executed again by React. That's one of the key ideas of React, that updating the state causes the component function to be executed again so that React can update the UI if needed. However, if this component function executes again, this fetch request also gets sent again. So we send another request, we get back data, we update the state, and the loop begins again. So this is not code we want to write like that. It would cause an infinite loop. So therefore, since that's not the solution for fetching the posts, how should we do it? Well, this is of course a common problem, and therefore React has a solution. It has another hook we can use. Now, the hook we can use to solve problems like this, where we effectively want to cause a side effect in our component function. So where we want to trigger some action that does not directly influence the JSX code, but maybe indirectly in the future, or that does anything else that's not related to rendering the UI. In such cases, we get another hook we can use, and that would be the useEffect hook, which is there to wrap side effects. useEffect allows you to safely run code like this without causing an infinite loop. But how does it work? Well, you execute useEffect like this, and unlike useState, it does then not return a value. Instead, it takes a function as a value and as a second argument, an array. So two arguments that must be passed to useEffect, a function and an array. Now I'll come back to the array in the future. Let's first focus on the function. This function will be executed by React for you whenever it considers this effect to require execution. And I'll get back to when it considers this effect to require execution in just a couple of seconds, but I can tell you that this second argument, this array, has something to do with it. We can, however, now grab our code and put it in there. And we could now also actually wrap it into an extra function. Fetch posts could be the name, which is an async function, which is defined inside of the effect function, so that we can move our code in there and actually use await to get our response, and then also get our response data by awaiting response.json, so that we have this more readable code. And then we update our posts with the rest data posts. I created this extra function in this effect function instead of turning the effect function itself into an async function, because useEffect takes a function that should not return a promise itself, but that instead should return nothing, or a cleanup function, which is not too important for us here, which I do of course cover in my complete guide course, but which we can ignore here. But we should not return a promise here for this effect function, and therefore we should not add async here. Instead, I create an inner nested function, which I then simply immediately execute inside of this effect function. And this trick allows me to use async await in here. But back to the effect function itself and the idea behind it. As mentioned, React will now decide when this function gets executed, and therefore when this function gets executed indirectly. And I can tell you that now, with this setup here, it will not always get executed when this component function executes. Instead, if we save this code and we reload the page, you see that now this post appears magically, and that's of course the post from the backend. And we can prove this if I go to the backend and I would edit the body here in posts.json and save the updated file, and I then go back to this app and reload, you see that was updated here as well. So this data is coming from the backend thanks to useEffect. But how exactly is this function working, and why is it now not causing an infinite loop? This useEffect function here, this hook, is now preventing an infinite loop from occurring by simply making sure that this effect function does not always execute when the component function executes. It executes sometimes when the component function executes, otherwise we wouldn't have fetched the posts, but not always. But when does it execute? Well, that's controlled with this second argument that's passed to useEffect, this array here. This array in the end specifies the dependencies of your effect function. And a dependency is simply any variable or function that might be defined outside of this effect function anywhere in your React components, in this component or some parent component passed down through props. And whenever such a variable or function defined outside of the effect function changes, receives a new value, for example, this effect function will be executed again. Now, if we have an empty array, it simply means this function has no dependencies, and therefore it will never be executed again. Instead, React will only execute it once, and that's when this component is first rendered. And technically, it gets executed after the component first rendered. So theoretically, the component first renders without any posts, and then it immediately executes this effect function where the posts get updated. But that's all so fast that we only see the final state here where the posts are fetched. But that's how this executes. And this now gives us fine-grained control over when this executes. So that's how we can handle side effects like sending HTTP requests. Again, we of course dive deeper into effects and all these things in my complete guide course, because that's the idea behind that course. But that's in a nutshell what you must know about useEffect and how it can help you, for example, for fetching data when a component is first rendered. Now we added the useEffect hook to fetch data, and this is all looking good, and if we load this page, the data shows up pretty much instantly. Now that's also the case because the backend is running on the same server, on the same machine, our local machine, as the frontend. And therefore this HTTP request and all these things are happening super fast. In reality, sending that request here for fetching or for storing the data might sometimes take some time. It's not that bad because in the end here we are fine with still updating the posts in our local state immediately. And we just send this request kind of behind the scenes, and it doesn't matter if it takes a second or two. But for fetching the data, it would be bad if the backend would be a bit slower. We can simulate this by going to the backend code, and there you find this line of code in the getPosts route here in this function, which you can comment in. This simply adds a delay. Of course, it's not realistic that you would add such a delay, but this is just for demo purposes to simulate a slower backend. If you comment this in and save this file, you can quit this server with Ctrl+C and restart it to make sure that those changes are taken into account. And now you will see that if I reload this page, I see there are no posts yet first before the data shows up. And this is not necessarily the ideal behavior because the user doesn't really see what's going on and it looks like there really are no posts until suddenly they do show up. You instead might want to show some loading text or loading spinner whilst the user is waiting for the data so that we differentiate between scenarios where we have no data and where we're simply still waiting for the data. And to achieve this, what we could do is in posts list, we can add another new state with useState, and that would be a state which I'll name isFetching, with the setIsFetching state updating function, and initially that's false, so it should be a Boolean value. And the idea is that we set this to true right when we start fetching our posts in here, and we set it to false thereafter. With that, we have this fetching state, and we can use that to show an alternative UI whilst we're fetching data. So in the JSX code down there, we only want to show the posts or the fallback text if we're not fetching. So if we're not fetching, if this is false and posts length is greater 0, we want to show the posts. And similarly, if we're not fetching and posts length is equal to 0, we want to show the no posts text. Because, and that's a new scenario, if we are fetching, then I instead rather want to show a paragraph where I say loading posts ... something like this. And I'll wrap this into a div here, which also centers this and turns it into some white text, like this. With that, if we save this, we now see loading posts initially until the posts appear. And that arguably provides a better user experience than showing this there are no posts message instead, which is technically wrong. There are posts, we're just still waiting for them. So that's how we could handle a loading state, and that's another improvement you might want to add when fetching data like this. Now that being said, there are more things we could improve here. We might also want to handle some error state and check if the response is maybe not okay. So if we had an error response, and in that case output an error message. And you can definitely try doing that as an exercise. Here I'll not do it because this is just a crash course getting you started. It is an improvement you might want to add, but I'd rather dive into more advanced and useful React features, which is what we'll do next. So we got data fetching and data sending, and this demo website therefore looks quite nice, quite decent, and we learned a lot about React. However, there's one last crucial feature missing in this website, which I'd also like to explore together with you. And that would be routing. Now what's routing? Many React apps, I would say almost all React apps, at least definitely if they are anything but simple demo apps, might want to have routing, which simply means that you want to support different paths and load different pages, different components in the end, for those different paths. At the moment, our demo website here only has one path. No matter if I click new post or not, the path up there, the URL, always stays the same. The disadvantage of this is that I, for example, can't link users to this new post mode. If I want to send a link to someone that allows them to immediately create a new post, I could try to copy this URL, but if I paste it in and hit enter, I end up on the starting page again, because this React app has no pages. And that should generally make sense because, as mentioned before, we're building a single page application with React. So we have only one page, only one HTML file. But the idea behind routing is that we can still support multiple paths by simply listening to URL changes whilst the app is running, or by evaluating the URL when it's first loaded, and by then loading different components for different paths that are encoded in the URL. So that for our domain /nothing, we load the landing page, for /products, we load the products page, and so on. That's routing. And even though React apps are SPAs, as you learned, there is a solution for still getting this behavior. And that's the React Router package, which is the most popular routing package for React. Because React itself has no routing capabilities built in, and whilst you could build your own solution, where you try to take a look at the URL, extract the path, and load different components for different paths, React Router is a powerful package that solves all these problems for you and that offers tons of features related to routing. Now, just as with all the other React parts, I dive way deeper into React Router in my full course, but we'll still get started with this super useful package in this crash course here. Now, React Router also has an official website, where you of course can also learn all about it. And it's also worth mentioning that there are different versions of this package. And for example, version 5 is still quite popular, but version 6, for example, works quite differently compared to version 5. And therefore, I also got separate videos where I explain what's new in version 6 and also in 6.4, which also added even more exciting features to React Router. In this crash course, we're of course going to dive into that latest version here. And for that, we first of all have to quit our development server here in the frontend application and run npm install react-router-dom. So not just React Router, but React Router DOM. This package must be installed, and that gives us React Router in this frontend application. Now with that, we can add routing, and what's really important to keep in mind is that we still have a front-end application. This routing happens on the client side, not on some backend. But it does still enable us to support different paths and simply load different components for those different paths. Now, which different paths could we support in this demo website? Well, of course, I still want to have the starting page where I show all posts, but I then also want to be able to get to this new post page here. So that should be a separate page, maybe still presented like this as a modal overlay, but it should get its own path, its own URL. And I also want to be able to click on my posts to load them in a modal on a detail page as well, so that I can also link to a single post if I want to. So I want to have these three routes: starting page, new post page, and post detail page if I click on a post. And therefore we need to tell React and React Router that we want to have these three posts. And we can do so, for example, in main.jsx, by first of all there importing something from React Router DOM. And the something we want to import is the router provider component, as it turns out. And you should render that component instead of the app component here. This enables routing and tells React Router that it should watch the URL and start rendering different components for different paths. But just by adding it like this, it won't work. And that hopefully makes sense because, of course, you also must tell React Router which components should be loaded for which paths, so you must configure the router. That's why router provider takes a router prop, which wants a route configuration object as a value. And that configuration object is created with a function imported from React Router DOM, which is called create browser router. We can then call this function to create such a route configuration object and store that in a constant and pass that constant, that configuration object value, as a value to the router prop on router provider. And now create browser router then takes an array as a value. And this is simply an array of all the routes you want to have, a list of route definitions. And a route definition is simply an object. An object which typically should have a path property where you, for example, define the path of a single route. So we could have multiple objects here, and every object represents one route, one path, and the component that should be loaded for the path. So here we could have the path /nothing as the main route, so to say, which then is loaded for our domain /nothing, which is equal to just entering our domain. So that's of course one important route we want to support here. And the path alone is not enough. Instead, you should also add the element property where you now define the JSX code that should be rendered on the screen when this route becomes active. So when this path is active. And here, in my case, that is simply the app component for the moment. So the component which we previously rendered there is now the component that should be rendered if the path is /nothing. With this simple change, if we save everything, the app still works as before because we load this app component for /nothing. So that's of course not too impressive, but if I, for example, enter /new, I get an error instead, which already proves that something's going on here. React Router is doing something because indeed it is telling me that it did not find this route. And that makes sense because I only defined this /nothing route. But that still works then. But of course, we don't just want to add one route, we wouldn't gain much by that. Instead, we want to have multiple routes. And for example, we wanted to have a separate route for creating new posts. So how can we add this new post component as a separate route? Well, we can of course add a second route here to this create browser router function. And then maybe have a path of create-post. This path is of course totally up to you. And then here we could say that we want to render an element, and the element should be the new post component. For that you must import the new post component, but then you can render it like this. And you can, by the way, render any JSX code of your choice here. Could also be some h1 tag. But of course here, in that case, I want to render the new post component like this. Now, if I do that, and I then enter create-post here, I indeed see this new post component here, not as a modal, and the rest of the app is gone, and it also doesn't really work, because upon submitting, this prop value is not received anymore. This value for onAddPost is not received anymore, because I'm using this component now without setting any props. But it technically, generally, still works. At least I can see this component. But of course, it's not rendered the way I'd like to see it. Instead, it should still be rendered as this overlay. And this button should, of course, still lead there. And therefore, we have to dive into another important feature offered by React Router. And that's the feature of creating layout routes. When building more complex React apps with routing, it's quite common that some routes should also have shared layout elements. For example, this main navigation bar here at the top should probably be visible on all routes we have. And to achieve this, you can add so-called layout routes, which are actually just normal routes, but routes that nest other routes inside of them. To add such a layout route, we could add a new route definition. The position in the array doesn't really matter here, but I'll add it as the first route. And then here the path is still /nothing, because I want to create a layout that wraps all routes no matter which path they have. Then we have to add an element, and here I need to add a new component. And for that, I'll actually add a new folder called routes to organize my components differently now. The components which are used as routes should go into the routes folder, and the other components which are used somewhere else will stay in the components folder. This is not needed technically, but makes this app a bit easier to maintain and understand. In this routes folder, I'll add a root layout.jsx file, though the file name of course is up to you. In there, we create a regular component function, which could be called root layout and which is of course exported. And then here, I want to return a fragment where I have my main header and then something else, which I'll add soon. For the moment, it's just the main header. And that should be a layout route, which is wrapped around other routes so that the main header is shared and then the content of the other routes is rendered below this main header. To make this work back in main.jsx, we can import the root layout route from routes root layout and set this as an element here, like this. And now the important part that must be added here to make this a layout route is that we add another key to the route definition, and that's the children key, which takes an array. And it takes an array of more route definitions. And here I'll then move these two route definitions into this root layout route definition. And that turns this root layout route definition into a layout route of these two routes, because these two routes are now nested routes to this route here, and they share the layout provided by that route. They simply are inserted into this root layout component, and therefore they share this main header. However, if we save this, you'll see that, yeah, the header is there, but the content is missing, and clicking new post also doesn't do anything. The reason for that is that indeed we are now sharing this main header component, but we're not telling React Router where to render the content of these nested routes. And that is of course something we should do. And we do that by going to the root layout and importing an outlet component from React Router DOM. That's a special component provided by the React Router package, which should be rendered in the place where the actual nested route content should be rendered, should be injected, so to say. So this is simply a placeholder where the nested routes can render their content in the root layout. And therefore, with outlet added here in root layout below the main header, if we save this, we now got the app component content back. And therefore, I now also have two headers here because at the moment, the app component, of course, still brings its own main header. But that's what we can tackle next. It's now time to refactor the code a little bit and clean it up a little bit to make sure that we don't have this duplicate header here, for example. So let's do that cleanup work. And I, first of all, want to make sure that this app component is a separate route in the end. And for that, as a first step, I'll actually move app into the routes folder because this is loaded as a route. And I wanna, as mentioned before, organize my components such that the route components are in the routes folder and other components, which are used as part of other components, are in the components folder. And I'll rename this app component here to posts because ultimately this should be responsible for rendering my posts list here. Now in this posts.jsx file, which was the app component, I'll remove the main header and I'll rename this function here, this component function, to posts, also in the export. And we can get rid of that main header import here as well. Now we can also get rid of the show modal handler because that was previously used by the main header. And we can actually also already get rid of hide modal handler here and get rid of these parts here and of this state because we'll have to change the entire logic of our posts list component and how it works soon. So for the moment, if I save it like this, if I reload, we show that list of posts and we don't have the duplicate header anymore. But of course, this button here still won't work. I'll get back to this soon. What I want to do first, though, is I also want to refactor the new post component and also move that along with its styles file into the routes folder because this is also loaded as a route. So here we have this new post component here. And with it being moved here, this button still doesn't work. But if for the moment I manually enter /create post in the URL, this gets loaded. However, not as a modal overlay above my post list. This does not work. As you can see, I have my post list here, but the new post page was not loaded as an overlay. And that's therefore some more refactoring which we have to perform. This new post component should still be loaded as a modal, and therefore inside of the new post component, I'll use this modal component. Previously, I used it here in posts list, but there I'll soon get rid of it. So instead, inside the new post component, I want to use this modal component as a wrapper around this form. And for that, you have to import this modal component from going up one level, components, modal, like this, so that this still gets rendered as a modal. And in the posts list component, I want to clean up this component. This should no longer be responsible for also adding new posts. Instead, that will soon be taken care of inside of the new post component. So in the posts list component, we can get rid of that code where we render the new post component in a modal. We can therefore get rid of this isPosting and also of the onStopPosting props. Get rid of these two imports, which we don't need anymore. And also, theoretically here, of that addPostHandler function, but I'll keep it for the moment because I will soon need that code again. But with that, if we save this, if I now go to create-post, it now opens as an overlay. However, not as an overlay above my posts list. To make that work, we actually have to turn this posts component into a layout component itself. Because whilst it does not provide some sidebar or main navigation, it still should provide an element that's also available in the new post component. And that would be the list of posts. So I'll actually add a children prop here to the app component, which was actually renamed to posts. So I'll rename it here as well in the import and when I use it. And then here in this array of child components, I want to render create post as a child component. So this new post component is now a child route of the posts route. So we have some nested layouts here, but due to this setup, we'll be able to render this new post modal as an overlay to this list of posts. For that, we just have to make sure that we also add an outlet here. And this can again be done by importing outlet from React Router DOM, just as we did it before. And then we could add it here above this main section. So now posts is technically also a layout route, you could say. And we get these nested routes here to achieve this look where if I now open create post, this is opened as an overlay above my list of posts. At the moment, that list of posts gets reloaded because I manually entered the URL and therefore loaded this page as a brand new page, just as if I clicked the reload button. But you see, it now is rendered with exactly the look I want to have, which is that we have this as an overlay. Though at the moment, closing this, of course, does not really work, and we also can't open it by clicking New Post. So that's something we should also change. So how can we make sure that clicking New Post opens this New Post modal? Well, we need to create a link between these two different routes in the end. And for that, we can go to the main header component, which is where I have this button, and we now must edit this component a little bit. We must replace this button with a link to this /create post route. That's in the end what we want to do. So for that, we could replace button with an anchor element, which is the right element for creating a link, and get rid of the onClick handler, and get rid of that prop, which we don't support anymore. And instead add the ref attribute here and point at create-post. If we do that and save this, the styling is a bit off, we get this underline effect, but we can ignore that. If I click this, it seems to work. But I say it seems to work because actually, if you watch this refresh icon, if I click New Post, you see it briefly changed to a cross, which means that technically a brand new request was sent to the server serving this React app, and we technically downloaded the entire React app again and started it as a new instance of that app, you could say. So it's just as if I manually pressed this refresh button. This works, but it means that we leave the single page application just to load it again, which means any global state would be lost, and we of course also unnecessarily download and execute all the JavaScript code again, which is not great for performance. For that reason, we want to stay in that single application world and just make sure that the URL changes and a new component gets loaded without sending a new request to the server serving the React app. And this is of course a common use case, and therefore we can import the link component from React Router DOM. And we should use this link component instead of the anchor element. Under the hood, this renders an anchor element, but it prevents the browser's default of sending a request. This link component doesn't take the ref attribute, but instead the to property, but we can and should then still target create post. I'll also now briefly go to my main header module CSS file, and there on button, I'll simply set text decoration to none to get rid of the underlining. But the more important part is the usage of link. With that, if we save this and we go back to /nothing and I click new post, you now see it did not reload the page, and you can also tell that it didn't do that by the fact that if I load this, you have this list of posts, and if I click here, you see in the background it's not refetched again. Instead, we're still on the same single page application, and that's of course the user experience we want to offer. It's way better than the other experience we had before. Of course, we now also want to make sure that we close this modal if we click the backdrop or if we click the cancel button. Also if we submit it, but submitting this and handling submission is something we'll handle later. Now, to also navigate when we click the backdrop of the modal, we can go to the modal component, and there we can get rid of that on close prop, because we can actually handle clicks inside of that modal component now, assuming that we always use this modal to wrap a page with it, so to use it as a wrapper inside of a route, and that we always want to go back to another route if we click on the backdrop. But if that is our assumption, we can add a function here, the close handler, which will be assigned to this onClick event listener on this backdrop div. And in there, I now also want to navigate, but now we have to navigate programmatically here, because this is now not a link, but instead an action that's executed when we click a div. We could replace the div with a link, but here I'll stick to a div also to show you how programmatic navigation works. Because sometimes you must initiate navigation actions from inside code, and this is how you can do it. You can import another feature, another function from React Router DOM for that, and that function is actually a hook, the useNavigate hook. A hook provided by React Router DOM. In React, you don't just have the hooks that are built into React. Instead, you can also create your own hooks, and you learn how to do that in my course as well. And therefore, third-party packages like React Router DOM also can create and share hooks. Now, useNavigate can be executed to get hold of a navigate function, which I store in a constant here. But this, in the end, holds a function. Therefore, we can execute it as a function here in close handler, and then we pass the path to it to which we want to navigate when it's executed. And we could navigate to /nothing to make sure that if I click on the backdrop, I navigate back to the starting page. We could also make this more flexible and use a relative path and use two dots here, which works in the same way as two dots work in the terminal when using the cd command. You go up one level. It's the same here for routing. You can use this special relative path here to go up to the parent route, so to the route above this route that's currently active. This would make the modal a bit more dynamic. It's up to you what you want. Here I'll use this approach, and therefore if this is loaded as part of the /createPost route, we would go up to the parent route, which is this / route here. So therefore now with that, if I save this all, we can still open and close the modal. We can also make sure that the cancel button closes the modal. For this, we can go to the new post component again, which is where we have this cancel button. And we could now also initiate programmatic navigation here again, but here in the end, it makes more sense to render a link again. Therefore, we can again import the link component from React Router DOM, and then replace this button down there with this link. Get rid of the onClick event listener now, and therefore also actually get rid of the onCancel prop up here because we're not using that prop anymore. And now we can go back to this link, add the toProp and tell React Router where to navigate to when this is clicked. And here we could again use 2 dots to simply go up to the parent route, which is the same as adding a slash here as an absolute path in this case. It's up to you what you want to do. Both works. So now with that, styling is a bit off, but if I click cancel, we now also close it. Now to fix the styling, you find an updated new post module CSS file attached, and you can simply grab the content of that and replace your new post module CSS content with it. If you do that, you will see that now styling looks better again. So that's how we can navigate between our different routes, and now we got almost the same behavior as before, but now with the advantage of having shareable URLs and with the routing being used for linking these different parts. And that's actually a big improvement over what we had before, because it means that we can now share links to the different pages that make up this app. And of course, the more complex your React apps are, the more likely it is that you need such shareable links and that you want to use routing for loading different parts of the website. Now, with routing added, we added another crucial feature to this application, a feature which is especially important in more complex web applications you might be building with React. And React Router, at least if you have version 6.4 or higher installed, also offers some amazing features that go beyond picking the right component for the right path. Instead, React Router, when using version 6.4 or higher, also helps with data fetching and data submission. And that's now the last part we're also going to explore in this crash course. Because of course here we are fetching data. In the posts component, we have the posts list component, and in there we are fetching data. We have this useEffect hook here where we load our posts and set our posts. We also have the code for sending post data here, but that code isn't used at the moment anymore, and I'll get back to that later. But when it comes to fetching data, we could stick to useEffect, but when using React Router version 6.4 or higher, we have a more convenient way of doing so. Because with that version, you can go to your route definitions, to the route that needs data, so the posts route here, for example, and you can add a loader property to that route definition. Now the loader property expects to get a function as a value, and React Router will execute that function whenever that route gets activated, so whenever it's about to render this element. That's when this function gets executed, and you can therefore use this function to load and prepare any data that might be needed by this route component or any other component used as part of that route. So any nested component used inside of the posts component, for example. Now, therefore, we could add the data fetching logic for sending that HTTP request here. But to keep this main JSX file lean, it's more common to go to your route component file, so in this case the posts JSX file, and there export an extra function, which typically is called loader, though the name is up to you. But loader is a common convention since this will be the function that will be assigned to that loader property in the route definition. Now that loader function here still executes on the client side. It's still code that executes in the browser. And therefore in there you can do whatever you want to do that could be done anywhere else in this app as well. Here I want to fetch my posts, and therefore I'll go to the posts list component and copy these 2 lines of code here. The state updating code does not matter here because this loader function executes outside of the component and can't manipulate component state. You will still see how we then get the posts into the component a little bit later. So I cut the code for fetching data, and back in posts.jsx, I'll paste it into this loader function. Now, since I use the await keyword here, we should add async in front of that function to unlock that keyword. And we can do that because this function, which will be assigned to this loader property, can be an async or a synchronous function. It may return a promise or it may not. React Router does not care about it. But if it does return a promise, React Router will wait for that promise to resolve before it then renders this route component, so this element which you specified here. And therefore here we can use async and then send our request to fetch all posts and extract the data. And then, that's the important part, we can return the data that we want to expose to the element that is rendered for the active route. So in this case, resData.posts. I return that as part of this loader. And then in main.jsx, we can import this loader by editing this import here, where we import the posts component function. And there we can also import this loader. And I'll give it an alias since we might have more loaders from different routes and we don't want to have name clashes. We could name this posts loader, but of course this name is up to you. So in the end, it's now this loader function here, which is assigned as a value for this loader property in this route definition, and therefore React Router will execute this function and wait for the promise to resolve before it then renders this element. And the data we return here in this loader is actually exposed to this element. React Router will make sure that the data returned here can be accessed in this route element or in any nested component, so also in posts list, for example. That's why we can go to posts list, and there we can now import another hook from React Router DOM, and that would be the useLoaderData hook. Now this hook can be called inside of the component function. Like all hooks, it must only be used inside of component functions in the end. And that gives us the data that is returned by this loader that's assigned to this route, which is the route that is active when the posts list component is rendered. So here I get my posts in the end, because in my loader here, I'm returning the posts. So that's what I get here with help of useLoaderData. Therefore, we can get rid of that posts state. We can also get rid of the isFetching state because the loading state of this route and this route component will be handled differently soon. And we can also get rid of this entire useEffect call here because we don't use useEffect for data fetching anymore. Instead, we use this feature provided by React Router. We therefore should also remove these imports of useState and useEffect. And then down there in the code, we no longer have this isFetching condition because we no longer have this isFetching state, so that should go away. And we also don't need to check for isFetching here anymore. I do, however, still want to check for whether we have posts or not. And posts is now simply coming from useLoaderData, which gives us the data returned by the loader that was called for this route, which is active at the moment. With that, if we save this, if I reload, you see nothing for a short period, and then it actually loads the page and shows us the posts. And we see nothing initially because now the behavior is that as long as the loader executes, this route element isn't rendered. So React Router waits for the loader to finish before it renders this element. And actually here, this even means that nothing is rendered on the screen if we first navigate to this page. If I instead navigate to this page after closing this page, it actually executes this behind the scenes. And therefore then we don't get stuck and have an empty page for a brief moment. But if we visit this page for the first time, we see nothing initially until everything has been loaded. Now, this might not be the behavior you want, and React Router also gives you ways of showing pages earlier and not waiting for the loader to finish. And I do dive into more advanced React Router features that help you in such situations as well in the Complete Guide course, but it's a bit beyond the scope of this crash course. The important takeaway here simply is that this loader is executed before this element is rendered, and whilst this might not be ideal in case of a slow backend as we have it here, it's a great solution for all cases where you don't have a slow backend. Because if I go back to my backend code and comment out this timeout here so that we don't have this slowdown on the backend anymore, and I then restart this backend server, you now see that it loads pretty much instantly if I reload this page, and therefore now we have a great user experience again, but we have way less code that must be written inside of the component since we're using this loader feature. And again, for situations with slow backends, there also would be solutions, and therefore you can handle all these scenarios with less code, which is of course great since it decreases the complexity of your app and means less work for you as a developer. So it's great that we can now load data with that loader feature, but what about submitting data? What about creating a new post? At the moment, this doesn't work. And of course, it should work. And for that, we can also leverage React Router. It's the new post component where we have this form in the end. We got a bunch of code for getting the user input and for then preventing the default behavior of the browser and doing something with the data. Now, what we could do is we could grab that code for sending that data to the backend and cut it from add post handler here and actually get rid of add post handler in posts list, making this component even leaner, and instead add it here in this new post component instead of calling on add post and on cancel. Instead of doing that, we could send that post data to the backend right from inside the new post component. And indeed, this would work, but it's still a bunch of code we would have to write here, especially since we probably also want to close the modal thereafter, which means that we then also have to add extra code for navigating to a different route programmatically. A better and more elegant approach is to also use a special feature offered by React Router. Because just as you can add loaders to your routes to load data before it gets activated and before the component gets rendered, you can add actions to routes. So to this route here, the create post route, we can add an action by setting the action property. And just like loader, action wants a function as a value. This function, however, will now be triggered when a form is submitted in that route, which means that here in the new post component, we could export such an action function to again have that code close to the component to which it belongs. And then in here, we could add our code for sending that request, like this. Now we still need to get the post data, but that's how we could get started. But how do we now get the data that's entered into the form by the user? Well, previously we had to manage our own state for that. Now, when we embrace React Router, this all gets much leaner again. We can delete that state and delete these functions that updated the state. We can also delete this submit handler and therefore also delete the useState import and get rid of the onSubmit event listener on the form element and get rid of the onChange listeners on the inputs. So we already got rid of a lot of code here. And instead, all we have to do here is add a name attribute to our inputs. So in this case, to the text area here. And then assign a name which we later want to use for extracting and submitting our data. So for example, here, my posts have a body and an author field here. And if I want to stick to that, to body and author, I could give my text area here the name body and this here the name author, so that I already use the keys which I want to use for storing my data here on these inputs. But what's the idea behind this name attribute? Well, it's a default HTML attribute that can be added to form inputs. And by default, if a form is submitted, the browser will, as mentioned earlier, generate a request, and it will try to send it to the server that served that website. Which would be wrong, because that server that's serving that website doesn't have any code to handle this request with the form data on the backend, because we have no backend code as part of this React app. But that's now where React Router comes in. We can import a special component from React Router, and that would be the form component with a capital F. And if we use that instead of the regular built-in form element, React Router will handle the form submission, and it will prevent that browser default of sending a request, but it will still gather all the input data, still generate an object with that data for us, and, that's the important part, call the action that is assigned to the route which contains the form with the capital F. So therefore now with this form component being used, React Router will in the end make sure that this action here gets executed, and therefore we can now also import this action function which I'm exporting here in new post, import this from the new post component file here, the action, and maybe also give it an alias in case we had multiple actions from different routes to avoid clashes. That could be the new post action therefore, and assign that as a value for the action property down there, like this. So that in the end, it's now this action function that will be executed by React Router if this form here is submitted. Now one last thing I'll do here is I'll add the method prop here to this form component and set it to post. Now it's important to understand that no actual post request will be sent anywhere, because this is still all client-side code, but what React Router will do behind the scenes is it will generate a request object with that form data included in it, and it will give this request object a method, which we could then use here on the action to find out which form was submitted when this action was triggered, in case we had multiple forms that belong to the same route with the same action. And even without that, it's kind of a good idea to use the semantically correct HTTP verb. And since we're creating a new post here, the post method makes sense, because that's typically the HTTP method that is used for creating resources. So with that, no request is sent to the backend. Instead, this action will be executed. And here you actually get some data argument. This is passed in automatically by React Router, and that's not the data of the form. Instead, that is an object which, for example, has a request property with that request object that's generated and built by React Router. So React Router calls this action function and passes this object that includes the request object that was generated to this action function. Therefore, here we can actually use object destructuring to get hold of that request object like this. And now this request object has a form data method. And when you execute that form data method, you get access to the data encoded in that form. So the data that was extracted by React Router when it analyzed that form and called that action. Now form data actually yields a promise, so we should turn this into an async function so that we can use await. And then here we got our form data object. And that is a rather complex object. It's not a plain key value store. Instead, it's an object that, for example, has a get method, which you could call to get the value provided for the body field, like this. That's how you could then extract the data that was provided by the user. Now, an easier approach here is to instead create a post data constant and use the built-in object class and call from entries and pass this form data object to it. Under the hood, this will simply then create a basic key value object where you have a body key with some value and an author key with some value in our case here, since we have body and author as name values in this form. So that's how we can extract the form data with help of React Router. Again, all still happening on the client side here. And therefore now we got the post data we need for sending that request. Here we can also await this to wait for the request to be sent. We could also get the response and analyze the response, for example, to find out if something went wrong, but I'll not do that here. And instead now, after sending this request, we can also call another function provided by React Router DOM, and that would be the redirect function. This is imported from React Router DOM, and you can call it in your action and loader functions to return the result of calling this function here. Now what redirect does is it generates a response object, which in the end is then returned by this action. And if you return such a response object, React Router will look into that object. And if it's a redirect response, which is the kind of response that is generated by calling redirect, React Router will simply move to that different route to which you're trying to redirect. So here we could pass a path of / here to make sure that after this action was called, we actually make React Router load a different route, the route with the path /, which in this case is of course this route, so that we leave the create post route and we move to this route instead. That's how we can initialize this navigation action. Again, all performed by React Router here. There is no backend code involved here. We're just sending a request to the backend, but this code here all runs on the client side in the browser. But with that all added, if we save everything and we go back and go to the new post area and try to add a new post like this, you see I am redirected. This new post shows up here. If I reload, it still shows up here. So it was indeed sent to the backend. We can also see it in post.json there. And therefore this proves that this action works the way it should. And we're now using React Router for sending and for fetching data. And as a result, you can see that our components got much leaner. We don't have to manually keep track of what was entered. We don't have to manually handle the form submission and prevent the default. We have to do none of that. We instead embrace React Router for sending and getting data, for navigation between pages. And that's why React Router is awesome, also for simple demos like this one, but especially, of course, for more complex websites. Now, with all that done, there's one last thing I want to implement, one last feature, and that is that I can click on one of these posts here. And if I do that, it simply opens as an overlay, just as new post, but with the details of that post which I clicked. To make that happen, we must add a new route, first of all. And that should be a route nested into this post route, since I want to have that same overlay effect as I do for a create post. So I'll add a new route definition here. And now the question is, what should be the path? And the path in the end should be / and then the ID of the post for which I want to load the details. And that's really important. I need to have that ID included in the path so that once the route becomes active, I can take a look at the path, get the ID of the post for which I want to load the details from there, and then load those details from the backend and display them on the screen. Therefore, we actually have different values for this path here. For one post, it could be this ID, and for another post, it would be this ID. Of course, we can't register all these routes here because we don't know in advance how many IDs we'll have and what the concrete values will be. Instead, we add a placeholder by adding a colon here, and then any name of our choice, like ID or post ID. That's up to you. I'll pick just ID. We can also add a / here to make this an absolute path, or omit the / to make it a relative path simply appended after the path of the parent route. We could have done the same thing for create post. That's up to you. Here I'll stick to absolute paths, but that's not required. So that's how we set up a dynamic route, as it's called, with a dynamic path parameter. Now we also need a new component that should be rendered when this route becomes active. And for that attached, you find the post details component with its JSX file and its module CSS file. Now this component here renders simply some details about the post which was loaded, here included in a modal, and also with some fallback content if no post was found for the ID that was provided. And I'm using useLoader data to get hold of the post. So I'm expecting to use a loader for loading the post for that route here when it becomes active. So we'll add that loader function in just a second. As a first step, I instead want to simply import this post details component from routes post details, and then assign it here as an element, post details, like this. With that, it's this component, the post details component, that will be rendered on the screen if we visit slash and then any post ID. However, as mentioned, of course, here we need some loader data because I'm expecting to get my post data with help of a loader. And therefore, I'll export an async function called loader here in this newly added post details component. And back in main.jsx, we can also import this loader and assign an alias. And that is why we use aliases, by the way. Otherwise, we would have two loader functions here, and that would be a name clash that is not allowed. So therefore, here I'll also assign an alias and name this post details loader, for example, and assign this to the loader property of this route definition down there. So with that, we also got a loader here. And now in that loader of the post details component, I want to send a request to this backend route here, where I also have such a placeholder, but that is Express.js, has nothing to do with React Router. It's just a common way of solving such dynamic path segments. But in the end, we need to send a request to our backend domain /posts and then /the ID of the post, which we want to fetch. And therefore here, I'll again use the fetch function, send my request to http localhost 8080/posts, and then / plus the ID of the post for which this route was activated. Now, of course, that will be different IDs. So we need a way of getting the actual ID that was loaded for this exact time where this route was activated. And we can get that from a data object that's passed to loader. Just as action receives an object, which for example includes a request property with details about that request object that was generated by React Router, the loader also receives an object, which also would have a request object, but which more importantly has a params object. This, by the way, also exists for action functions. And this params object simply allows us to access the ID for this route here. And here I'm using .id because I chose ID as a placeholder here in the route definition. If you chose something different here, like post ID, you would have to use that same identifier here, like post ID. This will give you the actual post ID that's included in the URL when this route is visited, and therefore it will send such a request to the backend to fetch the details for that post. Now here we can await that to get our response. We can then get our response data by awaiting response.json. As we're doing it for fetching all the posts, it's essentially the same code. And then here I simply want to return resData.post. .post because my backend sends back an object with the post key that contains the post that was fetched. Or undefined if no post was found, but I handled that use case here in my component. So therefore now we're returning the single post here. We're getting access to it here with useLoader data in post details. And we have registered this loader for this details route. Now with that all added, we also must make sure that we can reach this route. And to achieve this, I'll go back to my posts list component where I render my posts, and therefore to the post component where I have the actual post. And here I want to wrap that with a link. So I'll import the link component again from React Router DOM, add it here, and wrap the content here with that link, and then set the to path here to the ID to which I want to navigate. Now this again should be dynamic because different posts have different IDs. Hence, I expect to get the ID of my different posts as prop values here, just as author and body are different for different posts. And then I set this to value here to a dynamic value, which is in the end my ID, generating a relative path to that ID. So it's simply appended after the currently active path. That should give us a link that leads to a post with a specific ID. And to make sure it's styled properly, I'll go to post module CSS and add a short new style here, maybe below the post. Exact position doesn't matter, where I'll target the anchor tag that's rendered by the link component and set text decoration to none. With that, we just have to make sure that a value for the ID is passed to post. So in posts list, where I render my posts, I'm now also setting the ID prop, and I set it to post.id because my posts now have IDs since they're coming from the backend and there an ID is added. We could also use that ID for the key now, by the way, since it's a better unique identification criteria than the body. But we have to set the ID prop here on post so that there it can be used for the link. And with all that, these items are now clickable. And if we do click them, we view the details about a post. And we can click the backdrop to close this. So that's working as it should. And that's therefore it for this crash course, where we built this demo application, which allows us to create posts, view posts, and also load the details of a post with help of routing now. And along the way, you of course learned a lot about React. You learned all the essentials like working with props, components, state, and useEffect, and you learned how you can also add routing to support multi-page experiences whilst still being in a single-page application. You learned how React Router can help with data loading and data submission. And by the way, as you might notice, this means that your component code got drastically easier. There's way less state management in there. Indeed, here we have no state management at all anymore. And therefore now, at the end of this crash course, you got a solid set of skills, a solid foundation for working with React, for diving deeper into React with the official docs, with my complete guide, or for diving into frameworks that build up on top of React, like Next.js or Remix, which would allow you to build full stack applications with React instead of just front-end applications. And therefore, I hope that this crash course was helpful to you, and I wish you all the best for your future work with React.